Dear colleagues and dear all, welcome to this scientific writing workshop organized by Hamdan bin Rashid Al Maktoum Foundation for Medical and Educational Sciences and in collaboration with the Lebanese American University, the LAU. This workshop will be accredited with 6 CMA hours points by the Dubai Health Authority. And 5 speakers, you can see them on the screen, will accompany you throughout these 2 days, and they will introduce themselves during the different sessions. We have few things that I would like to remind you. The first one, please use for the 2 days the same Zoom link to access the webinar for both days. Also, we can post questions for the speakers into the Q&A box at the bottom of your screen. Remember, this is very important also, to fill in the poll or the survey that will pop up on your screen at the end of tomorrow's session. Okay, so tomorrow's session you will have a pop-up just to fill in the poll and in order to get your CME certificates. Those certificates can be downloaded from certificate.he.ae next week. So please use the same email address that was used for registration for the webinar. And finally, a recording of the session will be made available on the Foundation's YouTube channel. So enjoy these 2 days, and I'm sure that you will learn a lot of things. You have excellent speakers and very renewed speakers in this domain. Thank you very much. Abir, Dr. Abir Hani, the floor is yours.
Yeah. Thank you, Dr. Andre, for your kind introduction and for the instructions. It is a pleasure to be with you today. I will just try. Yeah, I'm pulling up my presentation. So I am Dr. Abir Hani. I'm a clinical assistant professor of pediatrics and neurology at the Lebanese American University. I finished my MD degree in 2008 at the American University of Beirut in Lebanon. And then I did a pediatrics residency at AUB for 3 years. After that, I went to Duke University in Durham, North Carolina, and I pursued a 3-year child neurology residency, followed by a year of clinical neurophysiology and epilepsy. I've had the chance to train and work with many good researchers and then to be involved in some research afterwards. And I co-authored many chapters, and I'm a member of many epilepsy and clinical neurophysiology organizations and a fellow of the American Clinical Neurophysiology Society. So I want to thank you all for being with us today. I want to thank the Hamdan bin Rashid Al Maktoum Foundation for Medical and Educational Sciences for this great initiative, much needed initiative on scientific writing workshop. I do not have any pertinent conflicts of interest when it comes to this presentation. And what we will be covering during this entire session, me and Dr. Aniela Abi-Georges, a dear friend and a colleague at the LAU School of Medicine, is we will be going over introducing what scientific communications are, their importance, the purpose, as well as the audience usually that is present. Following that, we will discuss how to draft each section, including the introduction, the methods, the results, and the discussion, followed by finally the ethical considerations in scientific publishing. I'll be covering the introduction to scientific communications, as well as drafting the introduction and the methods section, after which I'll take some questions because I'm sorry, I have another course that I need to attend to, and Dr. Aniela would cover the results and discussion section, as well as the ethical considerations. So let's get started. So what is a scientific communication? So it is the practice actually of communicating scientific information. And we often do that using specialized communication products like research articles, grant proposals, poster presentations, scientific talks, etc. And basically, when we think of scientific communications, I think it helps to keep in mind that we need to be mindful of what the audience or who the audience will be, what the purpose is, and what format we will be using. So what is the purpose of a scientific communication? Usually it allows scientists, researchers, clinicians to communicate their research questions and detail the significance that these research questions have both to expert as well as non-expert audience. It's like the storytelling for research. Basically, in a scientific communication, you would be telling the story of your research. And to identify the purpose of your scientific communication, you will need to answer these questions. Why are you doing or why are you creating this communication? What challenge or problem does this communication respond to? And what do you want to your scientific communication product to reveal or to convey? So as we try to communicate our information or our work, our research to others, these are really valuable questions to be thinking of. So when you're telling the story of your research, there's a sequence that we often all have to go through. So you identify the problem or the question and you communicate it to your audience. Why did you do the research? Then you go into what new knowledge has this research generated? Like, what did you learn from the research? And then finally, you have to tell why your research is important, how was it important to the audience, and how does it serve the greater scientific mission? Now, when deciding the audience of your scientific communication, the audience could be belonging to several categories. These could be experts in your scientific field, like peer reviewers, journal editors, grant reviewers and funders, conference organizers. They could be experts in another scientific field, and these could include also journal editors, grant reviewers, conference organizers or business people, or it could be non-expert people yet, like students, policymakers, journalists, or businessmen. And I think it's important to know who your audience is, because the language you use and the technical jargon that you use will have to be determined by the expertise and how the audience is familiar with your work and with your language. The formats that are often used for scientific communications include most common form is a peer-reviewed scientific research paper, but could also be a grant application, and these could be written or visual. Now we have a lot of scientific talks or videos or interviews that are being done, and these could be, again, oral and visual. You can have a poster presentation, often done in a conference, could be written, visual, or oral. Newspapers, magazines, or blogs sometimes take interest in certain discoveries or researches, and often this would be written. Podcasts are now very popular, or radio interviews, less common now, also can be a mode to disseminate your scientific information. So as we mentioned, the most common structure of scientific communication that we will be using as clinicians or basic scientists will be a peer-reviewed scientific research paper. And the main components of this would include the introduction, the methods, the results, the discussion, and the conclusion. And so without any delay, we will start with the introduction section. So how do we draft the introduction section? And what we will be doing in the coming several minutes, hopefully, is define the research question and its significance, help you kind of come up with a research question, help you understand how to conduct a thorough literature review and write one, and then how to write a compelling introduction that captures the reader's attention. So before we delve into the peculiarity of coming up with a research question, I think we all know this probably, but it's always a helpful reminder to keep it in mind. And so you start with identifying an initial research topic or a research question and a possible outcome. And then you conduct a literature search. And then you write a literature review, and then you specify what your aims, the research aims and questions. And based on what you're trying to achieve, you choose the appropriate research design or methodology. You identify the methods and the outcome measures over here. Then you will collect and analyze the outcome data, interpret the outcomes, discuss the conclusions and the limitations, and generate new questions, and then come up with another research question, and so on, and go forth. Go again and again. And this is what we call the iterative research process. And so the first step is coming up with a good research question. So how do we do that? So the research question is not just a grammatically correct question. Sometimes it can take weeks to refine a research question, and sometimes it can take longer. and it can take a career to ask and answer the question that you wanted to ask. So coming up with a good research question is very important, and it is fundamental so that you can conduct your study. Now, I like this outline for how you would come up with a research argument. You will find different references, different literature on the topic, but I thought that made a lot of sense. So the first thing is that you need to identify what the problem is in the universe that you're trying to address. What is unknown about this problem, and how will your research your research question will answer, hopefully, part of this unknown at least, okay? And we'll go through an example in just a little bit. So when we talk about the problem in the universe, that means that every research project should address a certain problem or question. A problem is something wrong or undesirable about how things are working now. So either we don't know enough, or we know something that isn't working very well, something is not right yet, and we're trying to figure out how to improve it. So let's say you want to do a research about electronic prescribing system and its effects on safety, okay? And so, okay, so how would you go ahead, how would you go about doing this? It is not enough to say, okay, I will be looking at the use of an electronic prescribing system and its effects on safety. We need to identify why this is important. Why do you need to look at that, right? So you should first explain why you're studying this subject, okay? And the way to do that is you explain what problem your study is trying to address. So the first part is actually trying to convince your audience that the study is important, and you need to convince them that the problem you are studying is actually important. So I'm going to study this. Why do you need to study this? Because it addresses, or it's going to tackle this problem that is actually very important. So try to explain what the problem is and try to convince people that this problem is relevant and is important. So how would you go about this? So in the example we're trying to address, what you could say is almost 100,000 patients die each year because of medical errors, with medication errors being the most common. The federal government is investing billions of dollars to support the use of electronic prescription system writing to improve medication safety. We studied whether implementing an electronic prescribing system led to fewer prescription errors as compared to use of paper-based prescriptions among community-based general pediatricians. So now it makes more sense. Now when we're trying to kind of promote for our study or write a grant or a proposal, now we're trying to justify why this is a big deal, okay? This is a really serious problem that we're facing. And we have to explain what is not known about the problem, right? So we have this problem, we have this issue, we convince people that it's really important. Here's what the literature says about it. Here's what the literature does not say about it. And it's actually what the literature does not say most of the time that is what we are interested in, because we're trying to cover that unknown or bridge that gap of the unknown, okay? And so whenever you come up with a research question, and even though you may have the best justifications, it's always important to anticipate critiques and sometimes to also critique yourself and critique the research question. So what? So why is this research question important? And I think this is a really good quotation. So if a study is not worth doing, it's not worth doing well. Okay, so you want to make sure that your study is actually worth doing. So let's go back to our example. What would we say? So we justified why this is an important problem, because a lot of patients are dying each year because of medical errors, right? And then medication errors are very common. Okay, and then the federal government is investing billions of dollars so that we have electronic prescription writing. What does the literature tell us? What is known? Studies have documented the effectiveness of electronic prescribing in the inpatient setting. Yet there has been little research evaluating the effect of electronic prescribing systems in the outpatient setting. So that's what's not known, right? Where the majority of prescription writing occurs. And so now I tell what I want to do. So we studied whether implementing an electronic prescribing system led to fewer prescription errors as compared to use of paper-based prescriptions among community-based general pediatricians. So we're studying the use of such electronic prescription systems in the outpatient settings where there has been very little research about this. So now I have the problem, I have what's known, I have what's unknown, and I have my question or my intent, okay? And so whenever you come up with a research question, it is important to try to see if it fits the criteria for being feasible, interesting, novel, ethical, and relevant. What do these mean? Sorry. So the finer criteria, the feasible, meaning can you recruit enough subjects? Do you have the adequate technical expertise to conduct the research? Do you have the time and the money, and can you manage to finish the project within the time scope that you mentioned? So this is what feasible means. Interesting, is it interesting to you in the first place? Is it interesting to people who share similar expertise or similar interests? Sometimes, is it interesting to the funding agency you're going to apply a grant for or something, right? Is it novel? Does it confirm or refute previous findings? Or does it extend on previous findings and provide new findings? So where does the novelty of the research question come in? Is it ethical to conduct this research question? And I think this is very important, especially as we come in the clinical sciences, as we try to do certain studies. So if you're trying to be part or to launch a clinical study to investigate whether an experimental drug may be helpful, and there's no treatment whatsoever for a very severe rare disease, is it ethical to withhold treatment even though it's experimental from people, and to have two groups, like a group with the medication or the intervention or the study drug and a group without it? So again, lots of ethical dilemmas that can come up, and you want to make sure that you cover this factor in your research question or research argument. And then you want to ask if it is relevant. So is the research question or research problem you're trying to handle relevant to the scientific knowledge? Does it help clinical and health policy? Will it provide future research directions? Again, these are good considerations to think about and to go through this checklist or criteria as you come up with your research question. Okay. So in summary, to come up with a good research argument or research question, you need to identify the problem that you have. You need to describe what's known about the problem, where the literature review will come in very handy, and we will talk about it very shortly. And then you need to articulate what is not known about the problem. That's the missing component. And then check to make sure that your research question meets the finer criteria. Okay. So you have completed the part on doing the research question, okay? And now you want to move to the next part of scientific research writing or scientific research process, and that's conducting a literature search and writing a literature review. So what is a literature review, or what is the definition of the literature review process? The literature review is where you identify the theories and the previous research which have influenced your choice of research topic and the methodology you are choosing to adopt. Okay? It should be a coherent argument that leads to the description of a proposed study. Okay? In brief, you are telling what is already known about the subject. Okay? You want to review the literature and figure out what is known about this problem. So how do we conduct a thorough literature review? Based on your research topic and question, there are three phases. You will do a search to identify the relevant articles. You will then need to read, analyze, and organize the material that you have uncovered in your search. Then you need to synthesize all this information that you gathered and write a literature review. And remind that this is a recursive process and it's not a linear process. So sometimes you have to do it and then redo it and keep doing it until you kind of gather all the info that are relevant for your research. So when we want to search the literature review, so one, we have to identify the key terms, okay? So for example, in order to identify the key terms relevant to your question, you might need to use certain models like the PICOS model. So you need to identify what your patient or population is, the intervention, the I being intervention, C, the comparison, O, the outcome, and S, the study design that you are trying to look for or that you're interested in. If you have medical education projects or searches, you might use the PO method. Who are the participants? what's the educational aspects you're trying to address, and what are the outcomes, okay? And then you will use these terms, these keywords or mesh headings, which means medical subject headings, to search relevant databases. So mesh headings, for example, are used in PubMed. You can use Embase, you can use Web of Science. There are many other now databases that help us look for different articles with different topics. Following that, you want to apply the screening criteria. So what are the type of setting, funding resources, language you want to limit or filter your search, by which you filter your search? What are the methodologies you want to use? And what I would recommend is always use the help of your librarian whenever possible. Most scientific, most schools of medicine now, or most schools in general, they have a dedicated librarian who will be very versed in the different databases and how to conduct good searches. And then sometimes you may need to go at this more than once until you identify the biggest pool of relevant articles. And then most databases give you the option to have your own accounts and username and password, and then you can save your searches and come back later and update the search. So definitely, if you have a librarian, feel free to communicate with them on that. Now, we could spend hours talking about the search component of the literature review, and that is an entire session in and of its own. But for now, we are just kind of telling you some of the basics. We will not delve into the peculiarities of the search component. Now, once you've completed your search and you've accumulated the data you want to review, you want to read, analyze, and organize. And it's important that we critically evaluate and select the relevant literature for your review. And for most of us who have done this process, went through a database and collected several articles, sometimes you figure out you get some hits that do not make sense, right? And so you need to kind of select what is relevant to your intent, to your review, to your research question, and what's not relevant. And then you want to organize the literature, take notes, and I think it's always helpful to have a visual diagram. And always start with using a reference management software like EndNote or RefWorks. Most institutions now have subscriptions for those, but then there are also some free reference management softwares that you can use as well. And so one of the helpful ways to kind of summarize the data that you gather in your literature review is kind of specifying who the author is, what the year of publishing is, the title of the article, what's the purpose, what are the key findings that are relevant to your research question, what are the strengths and the weaknesses. And I think this table helps you also at the end when you're trying to do your discussion, you can refer back to it. So this is a really helpful way to depict it. Some people like to go through a theme process. So they would, instead of a purpose and key finding, kind of go with themes and then strengths and weaknesses. So there are different ways to do this. It's just that it's helpful to have one way and to go about it. And then the third component is, how do you synthesize and write the literature review? Okay, so now you've read, you've analyzed, you've summarized, you're organized, but now you need to synthesize, to put this data together, and you need to organize your literature review around the ideas that will give context for your work and will help your argument. So the context meaning is what is known about the subject, what's the current knowledge, what works, when and where, what's the conceptual frameworks, how does it work, why does it work, and then whenever it's the most important step probably is trying to link your study intent to the literature review. Given the needs and the gaps that I've identified, how will my project contribute to ongoing discussion in the area reviewed, right? So this is very important. Like, the reason we're doing a literature review is to kind of tell people that there's a need, there's a gap in the knowledge, and that's what I'm trying to do in my research work. Now, what makes an effective literature review? A good literature review should be organized around ideas, not a kind of random list. It should form a narrative arc, we say, which means that it should kind of have a good sequence of ideas and should leave one interested in finding out what happens next. It should also form the core of an argument which will help kind of convince people of why your study is important. We say situate your study. It must be kept in check by establishing clear principles of relevance, quality, selectivity. So it's not like just lumping all the info that we read about. It should be relevant, it should be selective, and it should always booster the argument of why I'm doing a study. It is a process and not a product. And I think this is very important to remember, that many times we write a literature review, by the time the study is over, sometimes there are new info, there are things that change. So you need to make sure you go back, you update, or you enhance your literature review as well. So having done the research question, thinking of the research question, doing the literature review, now it's usually time to write your introduction. And so very important is to keep in mind the purpose of the introduction. Okay, so why are we doing the introduction? The purpose of the introduction is to tell the reader what the paper is trying to convey, what is already known about this issue from relevant literature, right, which is the literature review, and what the new or unanswered questions are that merit this investigation. So basically, you're gonna tell them what your research question is, what the literature review says, and then what's your aims or what's your question, right? A well-written introduction leads readers into the body of the paper, engaging them and making them want to continue. And we know that. So you start reading an article, and that was before the era where AI could summarize everything for you in a few minutes. But many of us still enjoy reading a good article. And so when the introduction is captivating and it really tells you why this is important, you feel compelled, you feel more engaged, and you want to continue reading. The writing style will vary depending on the journal, and I cannot emphasize this enough. It is very important that you look into what the author instructions, so that you or recommendations issued by the journal or the regulations, so that you make sure to follow the writing style that is requested of you. It is always good to aim for as simple and direct as a writing style as possible. You want to have your material and your scientific communication and your info accessible to the largest audience, to as much people as possible. So you want to keep things as simple and as direct as possible. Okay? Now, being done with the introduction section, you want to move to the methods section, right? And with the methods section, what we will go over are describing what the experimental designs that we use are, or procedures, how to ensure reproducibility and transparency, and highlighting the importance of using the appropriate statistical methods. Okay? So what is the aim behind the methods section, right? Why do we do a methods section? The main purpose of the methods section is to tell how the study was conducted, so that the study can be reproduced if necessary. And so the more detail, the more transparency, the more clear the methods section is, the more reproducible your study could be. The format that we use is usually, you need to be clear, transparent. We say formulaic, meaning that you need to have a clear understanding and to spell it out, what the study setting is, the time frame, the sample, the measures, the outcomes, what the data analysis plan will be, the methodology that you want to use. Most journals now require a subsection describing what statistical analysis you will be using, as well as the statistical software you will use. And some journals will require a complex methodology or survey to be placed in an online appendix or supplement. So if you have a very extensive methodology, so that people will not be so bored reading just through a lot of the methods section, you can put your extra info in a supplement. If a human or animal study is being reported, the authors should include a statement of IRB approval or exemption, if applicable, at the end of the methods section. And so when we talk about research methodologies, the two biggest research methodologies that we talk about are qualitative research and quantitative research. And then there are the mixed qualitative, quantitative methods. So with qualitative research, we're talking about research that helps you generate a hypothesis, which is usually focus groups, interviews, has more to do with, it's more like, it's more descriptive rather than being experimental like you would see in a quantitative research. With a quantitative research, we're talking more about scales, surveys, experimental designs, and a quantitative research is used to test a hypothesis. And qualitative research is used sometimes in clinical medicine, but the thing is that it's more used in social sciences. And most of what we use or we see or we read about is quantitative research. And sometimes mixed methods can be used to address gaps in generating a hypothesis and then testing it. So when it comes to choosing the study design, remember now we have a research question, we conducted a literature review, we specified our aims, and now it's time to choose the methodology or the study design. And so when it comes to the question of what study design should we choose, usually the answer is that more than one study design can be pursued for the same research question. But how would I use? If I have more than one study design, what would guide me to choose one study design over the other? We need to choose the study design that is feasible and that maximizes validity. Okay, I think that is very important to keep in mind as you come up with your research design. So we will be focusing in the coming remaining of my talk on quantitative research methodology. And we have two components. We have the observational research design, whereby it includes cohort studies, prospective or retrospective, cross-sectional studies, and case control studies. Whereas experimental designs, study designs are classified into non-randomized or randomized study designs. And we'll go over the details of these in the subsequent slides. So what differentiates the observational from the experimental designs? The observational, as the name implies, you as an investigator is an observer, meaning you have no control over which participants will have the exposure of interest and which participants will not. Meaning that, so some participants got a certain risk factor, others didn't, and you could not control that risk factor or that exposure or a medication or something like that. In the experimental study design, you as the investigator get to experiment or control which participants have exposure of interest and which participants do not, okay? And so this will become a little bit clearer as we go through detailed examples. So we'll start with the prospective cohort study design. In a prospective cohort study, you would follow groups of subjects over time. And so in all the studies that I will show, you will be selecting a sample from the population. I mean, none of us can study the entire population, so we always select samples. In a prospective cohort study, you will select samples at the present time, and you'll select samples with the risk factor present, samples with the risk factor absent or without the risk factor. And then you will follow them into the future, and you have to determine the future. Will it be 1 year, 2 years, 30 years? You determine that in your research question or proposal, and then figure out who among those folks ended up having the disease and who didn't have the disease, and then do your analysis, okay? And we'll have a concrete example to make things a little bit clearer for all of us. In a retrospective cohort study, what you have as present are people with the disease or people without the disease. And then you can dig into their charts and see in the past, which of those people had the risk factor and which of them didn't have the risk factor of interest, okay? So the thing with the cohort study is that it has several advantages. It can help you infer causality. It can measure incidence. But cohort studies tend to be expensive. They're not very practical for rare outcomes or rare diseases. And the assessment for therapeutic effectiveness may be biased by many factors. And so it's not like an experimental design whereby you can control for several variables and then check more confidently for therapeutic effectiveness, okay? So we're going to take an example and we will go through several study designs that could be done with this example or research question. So let's assume you're looking at children between the ages of 2 and 18 years, and you want to check whether vitamin D deficiency is associated with a higher rate of fractures compared to children with normal vitamin D levels, okay? So how would you do such an evaluation? Using a prospective cohort design or using a retrospective cohort design. So let's have a look at this example. So if you're going to be doing a prospective cohort study, what you will do is you will select a sample from the population and you will see, okay, I'm going to check and I will record or register these children who have vitamin D deficiency, and I will check who are the children who have no vitamin D deficiency. So ideally, you need to check children between 2 to 18 years in your practice who have a vitamin D level check, right? Who have had it tracked or in whom you plan to check a vitamin D level. And then you'll say, well, I want to see if they're going to have a fracture. And you need, like, this is not a very refined research question. It's just intent for the only intent is to try to do these research designs. So then you will say in a year or in 2 years, I want to check how many among these children are going to have fractures and how many will not have fractures. Okay, so this is an example of a prospective cohort study design. Now, a retrospective cohort study design will look into, you can do different things, right? So you will do in the present, you can survey and see who are the children who have fractures and who do not have fractures. And then you want to go back and who had vitamin D deficiency or who didn't. Or you would pull up the charts from your clinic and try to get like a sample of the children who had vitamin D level check whether they had low or high vitamin D levels, and then check now whether any of them had fractures or not. So it could be done by either way, but basically you're going back in the chart, you're doing a retrospective chart review to kind of figure out this study design. Now, the second observational study design we'll talk about is called a cross-sectional design. So in a cross-sectional design, the investigator will make all the measurements on a single occasion. And it's best helpful to examine associations between outcome and exposure. And what that means is that you have a big population, you're going to choose a sample. And in this sample, you will do this 2x2 table whereby you say, how many people have a risk factor with the disease? How many have a risk factor without the disease? How many have no risk factors, but they do have the disease? Sorry about that. And how many people have no risk factor and no disease? Okay. And so you will compile this table. And so that's what we mean, taking your measurements all on at one occasion. So the good thing about a cross-sectional design is that it is a good for description. It is relatively quick and it is relatively inexpensive. The problem is it can only tell us some associations, but it cannot determine causality. So again, if we look at our example, okay? So in children ages between 2 to 18 years, is vitamin D deficiency associated with a higher rate of fractures compared to children with normal vitamin D levels? Okay. And how would you go ahead and design a cross-sectional study to answer this question? So let's look at this together. So you will choose your population. So you have your population, you'll choose your sample. So let's assume you're in a clinic setting, let's say a general pediatric clinic setting. You may be in a more specialized pediatric endocrinology setup, and you say, okay, I'm going to survey or I'm going to take a sample of patients I've seen within the past 2 months, and then I will record who had a vitamin D deficiency with fractures or vitamin D deficiency with no fractures, who of them was vitamin D sufficient but had fractures, and who was vitamin D sufficient and had no fractures. And you would do your 2x2 table. Now, usually for such type of designs, especially if the outcome is rare, you might need to take larger numbers, okay? Or a longer time window so that you capture a bigger sample size. Now, continuing with the observational study designs comes the case control study. And the case control study is, as the name implies, you will select a sample from a population of people with the disease. These are the cases. Then you will select a sample from the population at risk that is free of the disease. These are the controls. And then you want to measure the predictor variables. So how does that look like? So you have a population, you choose your sample, and you choose a sample, you will have all the cases who have a certain outcome. You choose a controls, and when we say controls, meaning you're trying to control for biases or for certain variables. You choose a sample with no outcome, and then you check who was exposed to the risk factor, who is not exposed in the outcome group, and then in the let's say, healthy group or no outcome group, who was exposed to the risk factor and who was not exposed to the risk factor, okay? And so in our example, let's say in children ages 2 to 18 years, the question is vitamin D deficiency, will it be associated with a higher rate of fractures compared to children with normal vitamin D levels, okay? So how would we do that in a case control design? So what you would do is you will check a sample from your clinic or a group of clinics and get the cases with children with fractures. And then you can get a sample of controls. Maybe you'll take their siblings, like to control for other factors, or maybe you'll take you would match them to children with the same age group, maybe same socioeconomic status, same gender, and trying to control for as many risk factors as possible. And then in each of those, you're going to check, assuming they had a vitamin D level checked, were they in the children who had fractures, did they have how many had vitamin D deficiency? How many had vitamin D sufficiency? And same thing with in the children who had no fractures, how many of them had vitamin D deficiency and how many of them was vitamin D sufficient as well, okay? Now we're done with the observational study designs. We mentioned cohort, prospective, retrospective. We mentioned case control and cross-sectional studies. And now we come to the experimental study design. In the experimental study design, you have a population and you choose a sample. And then, as we said, in the experimental study, you can experiment, you can control which group or which participant will get the exposure of interest and which participant will not. So you assign participants to be exposed to a certain risk factor or intervention, or to be in the non-exposed group. And then you follow them over time and you check whether they had the outcome of interest or they did not have it in each group. Now, the good thing with experimental study designs is that the investigator can apply a treatment or intervention and observe the effect on outcome. So it is the best determinant of causality, and it enables us to control bias more so than we can in observational studies, because we can randomize patients, we can blind patients or blind investigators and patients. The disadvantages is usually feasibility. Do we have the time? And more importantly, the cost, like making a placebo or designing a placebo, having the numbers so that the study is powerful enough usually requires collaboration of multiple centers. Sometimes the studies could be multinational, and these tend to require a lot of time, a lot of cost, lots of manpower. And then the other big consideration, as we mentioned before, is the ethics of this. So if I have a rare disease and there's no treatment and I'm coming up with a very promising treatment, is it fair, is it ethical to give it to one group and not give it to the other? Or can we do a crossover? Shall we do a crossover, or what's the best way to go about it? So kind of you need to attend to the ethical considerations that often come with experimental study designs. So one more time. Again, you have these children between 2 and 18 years. Will vitamin D deficiency be associated with a higher rate of fractures compared to those who have normal vitamin D levels? And how would we go about this in an experimental design? So let's look at this diagram. So what you would do is you will choose children with vitamin D deficiency, right, in your practice, in your group, or in a bigger practice. And then you'll decide to give people some children you're going to give vitamin D therapy, and some you will give placebo, and you have to decide for how long you want to do this. And then you want to decide how long you will monitor them and figure out, in the patients who got vitamin D therapy, did they have, how many fractures did they have, how many of those ended up having fractures, and how many didn't have any fractures? And in those who got the placebo, how many had fractures and how many didn't have fractures? And then the question is, do you want to blind this? Do you want to do a blinded study? Do you want to do a randomized study? Is it okay if a patient have vitamin D deficiency not to give them vitamin D therapy? So again, you might want to do a crossover design, or you might want to give 2 different doses of vitamin D therapy, depending on how your discussion and your regard to the ethical considerations of the study are, okay? And so when we talk about quantitative research study design, as we mentioned, keep in mind that there are the observational, which are usually the easier to do for medical students, residents, because they usually do not have access sometimes to the time or the cost or the funding that experimental study designs require. So with observational study designs, you can choose a cohort, cross-sectional, case control, depending on what you're able to do. And then in the experimental study designs, you would do a randomized or a non-randomized interventional study. And so once you've decided on your study design, it's important also to decide on what statistical methods you will use in your study, okay? And now it is very common practice, and some journals even request that a statistician be on board with the research team. And so try to get a statistical consultation whenever possible. And this doesn't mean not trying to be well-versed with the common statistical methods that can be used or kind of getting to know how to use a certain statistical software, but I think it's always helpful. There's extra insight that can be offered by your statistician. And it's important to involve the statistician early on in the research process. It is not helpful to involve them after all the data have been collected, because sometimes there are certain variables that should have been collected, or certain numbers, certain sample sizes that should have been collected or done that haven't been met. And so it's really very hard to go back and try to repeat all the work again. So in the planning phase, it's very important to get a statistical consultation so that you can decide on what's the best study design, what control group you want to use, if there is a control group, what your power calculations are, especially if your study is not descriptive, like it's quantitative. What is the study sample? What are the variables to study? How much power do you want your study to have? So these are all very important considerations. Once you've collected all the data, then the statistician will help organize and analyze the data. And hopefully you would have agreed on what statistical methods, what types of tests you want to use, and that's when you can go ahead and use those. And the statistician can also help you kind of draft the results section, or help you in the assist you in drafting or reviewing the results section, and help you in kind of what's the best way to show your results in figures or so. And I think Dr. Aniela will tell us more about these sections in a little bit. And most institutions actually have statistical consultation resources available. But if your institution does not have, you may be able to consult with experts at another institutions as well, or collaborate with teams who have more available, maybe statistical consultations, okay? And so when it comes to statistics, I by no means am the best expert to tell you about this. I do know that we need to know some basic definitions so that when we come to kind of talk to a statistician about what our study shows, to have the to understand what's being told to us. So this is a useful slide with some basic definitions for the most common terminologies that you need as you conduct basic clinical research studies. So the power of the study tells us that assuming that there is an effect, what's the probability of detecting it, okay? The p-value tells us that assuming that no effect is present, what is the probability of finding one by random chance? So you want your power to be high, your p-value to be low, right? The alpha error, or the alpha is the, which is also equivalent to the type 1 error, is the probability of finding an effect that is not really there, okay? The type 1 error is finding an effect that is not really there, which is equal to the alpha error, or it's a false positive result. The beta is the probability of missing an effect that is present, okay, which is called a type 2 error. So there is an effect, but you missed it. And this is equivalent to so the type 2 error is the beta error, or the false negative. Now, the odds ratio, it is a ratio. It is the odds that an exposure and outcome are correlated compared to the odds that the exposure and the outcome are not correlated, okay? And then the correlation, so you will have to use different methods or ways or statistical means to assess for correlations. The relative risk tells us that if there is an exposure, what the relative risk is the absolute risk of one outcome compared to the absolute risk of the alternative outcome. Okay, now these definitely can become clearer and more applicable once we have a more detailed study on or more detailed lecture on statistics. But for the time being, I decided to just give you an overview of what some of the statistical definitions that we use, and will not delve into all the statistical into all the statistical details that we have to know a little bit about as we write our research articles. So with that, I tend to go a little bit fast, and I wanted to have some time for questions, but I guess I finished pretty fast. But I'll be happy to take any questions or review any information if you think I went over it pretty fast, okay? And thank you guys for listening. So
thank you so much, Dr. Abir.
sure.
We have a lot of questions here on the Q&A box. I don't know if your screen is stuck just for me or it's...
I will stop sharing. Do you want me to stop sharing for now, or?
Yes, I think that would be better, unless you want your slides on.
No, I'm okay with that. I'm okay.
Okay.
Yeah.
Okay.
Actually, I'm not sure I'm sharing. Oh, I'll stop share. Can you see my video or yeah?
Yes, I can.
Okay. I'll stop. Yeah.
So we have a lot of questions. Like I said, I don't know if we have enough time to take all of them, but we can definitely take a few.
Sure.
So about introduction, because you started with that first, we have a question from Laila Al-Kamali. We'll take two questions on the introduction. So she asks, do we usually start by writing the introduction first? So that's one question. And then there was something else here about introduction as well that I saw, which says,
Okay, Pratibha, if you want, we can go in the order of the questions, and I can answer them. We don't.
So do we start by writing the introduction first?
Yeah. Thank you, Laila, for this very valuable question. And I think there's no right or wrong here. So if you have so most of the times you would have your research question, right? Or research idea, and you want to refine it. But the first thing we tend to do is to write the literature review, right? And so, or we'll look into that, we research it. And it is helpful, I think, to always have your literature review early on and kind of have it lead into the argument, like what's known, what's not known, what gap are you filling? And so having done that, you would have done basically almost most of the introduction. So many times you end up completing the introduction first. Now, some people like to write a methods section as well as they're writing their thoughts and how they want to design the study and stuff like that. But I think it is important to complete a literature review before you go into all the methodology and how you want to make it. So it makes sense to write the introduction first.
Right. So the other question we have is on research questions. So this is Gorashe Amir, and he says, please, can you expand on research questions and the criteria for a good research question?
Okay. So let me just...
That would be the second question from the top right.
Yeah, from the top. Yeah. Okay. So I'm not sure I understand what we want to expand. So let me try to answer this, and if still not answered, Gurashi, please let me know exactly what you would like me to expand on. But so usually, how do you come up with a research question? So the most common way to come up with a research question is when you have a patient or you have a case, and there's some controversy about the management or about what happened, or you're not sure, there's a controversial management or therapy plan or diagnostic scheme or whatever that is. Or you, for example, if you go to a conference and you see people talking about an idea that's of interest to you, if you read a certain article, so that kind of sparks your interest into a certain topic, right? And then what you need to go do about this topic is once you figure out, okay, I'm interested in answering this or in clarifying this, So you would go ahead and then you would check what people have done. Has anybody answered this question before, right? And that's when you go to PubMed, for example, and you may write some basic search and try to see, is there anything relevant? And that's when you collect what's known about this topic. And then if you figure out that, people haven't researched this idea that I have yet, then you would try to convince people that it's worth pursuing. So if you're a student or a resident, you want to convince your mentor, your faculty, that you can do it. If you're a junior faculty, maybe the senior faculty or some other mentor, or if you are already an established faculty, you just have to, maybe you want to get funding and you want to submit a grant or something like that. So very important is first to have the research idea, and then try to see what has been done and how people have so for example, if I have a research idea and somebody had a similar research idea, I might still go and see what type of research they did, how did they look into it, what variables did they use, and try to see how will I be novel in what I do. So to expand on the research question, basically you have to research more about it and kind of figure out what people have done, if they've done something similar. And then I don't know that it's now in the answered section, maybe. Yeah.
Oh,
And
yes.
then what are the criteria for a good research question? As we mentioned, I would go with the finer criteria. So is it feasible? Is it interesting? Is it novel? Is it ethical? Is it relevant? So these are the criteria or the checklist I would go through. Yeah.
Okay. All right, thank you. We have a few questions on AI and the use of artificial intelligence. So one of them is again from Laila Al-Kamali, and they ask, what do you personally think about the new AIs that are prone to being able to figure out research gaps and generate insightful research questions? And then we have another anonymous attendee who asked us, to what extent can we use AI in doing the literature review?
Yeah, absolutely. So yeah. So I think AI is something great, okay? And it is something we will be using more and more of. And however, I think so when you come up with a research question or an insightful research question, AI can do it, right? I mean, let's agree on certain things. You can feed it whatever information, you can have the best, it has very fast algorithms. It will probably generate a good research question. My only take on this is that you want the question to be relevant to you and your interests and what you think. And that's why I think it's important that you be the one feeding the AI what your research interest is or what your idea is. And then it can come up with a perfect way to, like, to help you formulate or put it together or maybe make the best argument. But I think the human input in this matter is going to be very important, because you want a research question that is of interest to you. A research question that would make you persist when you get into trouble. Like if I have AI generate a research question that looks so wonderful, but I'm not very passionate about it. As soon as I have more work elsewhere, or as soon as I get stuck somewhere, I may not pursue it as much as I would if this was something that I came up with or that is of passion to me. So use AI, but be careful to feed in information that is more relevant to you and it's more interesting to you. Now, the other AI question is, I certainly think you can use AI in synthesizing the literature review. You just have to be mindful that the algorithms are not perfect yet. So there have been many reports now of wrong data sometimes in an AI generated report or article or so. So yeah, you can use it, but use it with caution. Like you may not need to read the whole article, but make sure you've read the abstract, the basic info about the articles that the AI is summarizing. Yeah.
Yeah, right. And the AI tool that you would recommend would be?
So I'm not yet very versed on AI tools, to tell you the truth.
Okay.
I mean, I've used ChatGPT so far. This is the best I've used, and I've resisted using it for a long time because I've always had this thought that I will be less reliant on myself and on my creativity. But I don't think that's gonna hold for too long. I started using ChatGPT, and I think it's an amazing world. And I'm starting to do some courses on AI so that I get more I can get more information. I've heard about many softwares, but I did not, or platforms, but I did not use many so that I can recommend.
Right. Okay. So a question from Suhaila Naz, who asks, how do we decide sample size based on the study designs?
Yeah, so there are specific algorithms for that. And so in most softwares that you may use, like SPSS or other softwares, and sometimes there are online platforms whereby you can say that, okay, I'm going to be doing a cohort study, and this is the power I want, and this is my p-value, and how much that would, there are mathematical formulas that are used to determine the sample size. And a statistician can definitely help you with that. But then again, there are like these online statistical calculators that can do this for you.
I'm going to take the first question, which was how do you, and this is relevant because one of the reasons we're doing this, this workshop is because we have these awards, which we mentioned in the beginning. And one of the awards that the Hamdan Foundation has called for is for young medical professionals to write a paper and submit, and this is eligible for an award. So here's a question from a student who's asking us how to find ideas for a valid topic for a systematic review as a student.
Excellent, very good question. So I think the most important thing first is to choose a topic that you're interested in, okay? So if you're interested, I don't know, you're interested in pediatrics, you're interested in neurology, you're interested in orthopedics, choose a topic that is in your field of interest, one. Two, choose a topic that has presented some controversy, okay? Or whereby people do not know enough about the best or ideal practice, right? Or there are no clear standards of care. Like if we have things that are so clear cut, we know what needs to be done, then what's the point of doing a systemic review, right? And so choose something that is interesting to you. Choose something that is a little bit controversial, meaning that with some ambiguity maybe about it, a topic, and then make sure that there are some studies about it that have been done so that you can review them in a systematic way, to have a systematic review or a meta-analysis. And I think it's always helpful to check who the faculty or the mentor or your teacher who has been experienced in doing systematic reviews. And usually there are always one or two in each school. And so you can go to them and you can brainstorm and you could tell them, I'm interested in this topic, and what do you think? Should I pursue it? Because again, there are guidelines and there are formats, like we cannot cover everything now, but there are definitely criteria that you would use to do a systematic review that is a little bit different from a scientific paper, and so on and so forth. But I would say go for something you're interested in, go for a topic that has some room to people are researching or investigating, and collaborate with somebody who has experience in such reviews.
Okay, thank you. There is a question here that says, sometimes it's hard to summarize information from the research paper. So how do you do that? This is Sana Fatima.
Yeah, so the important thing is, so I'm assuming you're doing a literature review and you want to summarize that research paper.
I guess, yes,
use it later. Yeah. So if we're going to do this the hard old way, you're not going to have AI do it. And even if you have AI do it, I think the important thing is to read the title, read the abstract to start with. Okay. And it's important to do this before you go into the research article, because if it is not very close or very relevant to what you're interested in, you don't need to read the whole paper, right? So usually by reading the abstract, you will understand what the main aim is and what the main conclusions are, like very briefly, but you wouldn't know the methodology and stuff like that. So sometimes I would definitely read the abstract very closely. I would read the introduction kind of fast, especially the first two paragraphs, because I know, especially if I know the literature review and I know about the topic, but I will read like the last paragraph in the introduction, and then focus a little bit on the method section and go through the figures and diagrams and not have to read every single word, right? And so if it is relevant and it is really close and it's really important for your article, then, or for your for the research that you are doing, then you would need to a little bit go into details And basically, you can use the table template that I have, like whereby you say, what is the main finding of the study and what are the weaknesses and the strength? Like this you would find maybe a little bit later in the discussions, and maybe you'll figure out that there are some weaknesses and strengths. So initially, the most important part, I would focus on the abstract and a little bit of the methodology, and look at the figures and the diagrams and figure out, is it really important for me to read every single word or to go into depth? And then if it's relevant, then I would do that, and then I would summarize it. There's really no like wonderful or correct way of doing this. That's one way I would do it. And then other people may have different ways.
Okay, we have a technical question here, so I'll take that, and maybe 2 more questions after this.
Sure. I think we have some
yeah.
time, so I'm okay with answering many questions.
Okay. All right. So this is Dr. Ahmed Abdulaziz, and he asks, what is the relation between p-value and sensitivity?
Yeah. So I had some slides on that, but I did not include them. I dropped them at the last minute. And so when it comes to the to determine the sensitivity, and usually with sensitivity and specificity, we are talking about diagnostic procedures, right? So the sensitivity, so when you're trying to assess whether there is a certain sensitivity or specificity of a certain test, you can determine a very low p-value so that you have the best sensitivity and specificity possible. Now, there are some formulas that I have not mentioned that help you determine how to calculate the sensitivity and the specificity, but I would rather not go into all these details later on. If you want, you can email me. I have included my email, and I can share it with Dr. Stephanie as well and the team, and we can have some more detailed discussion on that, because I'll need to show you the tables and how we go about calculating this. Okay.
Okay, thank you. Another technical question. What is the best study design for survival-based outcomes?
What is CBC? Okay. Yeah. So survival-based outcomes. So usually these are mostly done through observational cohort studies, right? So you want to make sure, you want to look at certain people. So having said that, I don't know if you mean oncological studies. Mostly they look into survival, or maybe survival post certain procedures that are more critical, cardiac or others. But usually survival and like these measures that take a long time to happen sometimes, the best method is a cohort kind of observational study design. Now you can definitely have an experimental study design that kind of becomes, so you can do an intervention and then check how much this intervention impacted survival or mortality. But I mean, ultimately it becomes more of an observational type of study, because you gave the intervention and then you're seeing how much they survive or they don't survive. So it becomes more of an observational type of cohort study, I would say.
Mm-hmm. So a related question maybe. So Ahmed Al-Amin, he asks, if I conduct a clinical audit about using an X-ray in head trauma patient and collected data for that in the previous months, would this be a retrospective cohort study?
Let me just try to figure where
so
that.
it's somewhere
I saw
towards
it.
the
I saw
end.
it. Yeah. So if I conducted clinical audit about using an X-ray in a head trauma patient and collected data for that in previous months, this will be a retrospective cohort study. So you're trying to do a clinical audit, how many patients used X-ray in previous months. So so let me get this straight. So you want to look into, so you want to do basically a chart review about how many patients in the previous months have had X-rays. Now, I don't know what the research question is, but anytime you go back in time and you look at data, or you try to kind of extract data, this is an example of a retrospective cohort. But I mean, you need to have a reason why you're doing an X-ray. Like, is it like an audit to make sure they're not doing much, or is it an audit to see what the outcome has been? Like, it's not clear to me what your question is, but I think whenever you go back and do a chart review, it's more considered more of a retrospective cohort study, usually, yes.
Okay. Is there a question that you find interesting, Dr. Abir, and you'd like to take it up?
Yeah, let me see if I can go through some of these real quick, because some of them are quick questions. So are finer criteria recognized or only for internal use? So they are more really for your own internal use. They're not like there's nobody that will request you to have these, to my knowledge, but it's helpful to use them, really. What is the difference between testing hypothesis and generating a hypothesis? So that's a good question. So, so with generating a hypothesis, meaning we don't know what is true about a certain condition, okay? So let's say I want to say that smoking leads to heart attacks, okay? Or to coronary artery disease, right? So that is me coming up with a hypothesis. Now I need to test this hypothesis. Okay, so does smoking really cause coronary artery disease or increase the incidence of coronary artery disease? So I will need to do a quantitative study to test the hypothesis, okay? I hope that made it clearer. About the review of the literature, should we use the literature review to answer the research questions identified for the study? If I understand this correctly, the answer would be probably no. So the review of the literature is, so you can use it to see if somebody has answered your research question before. Yes, you can do that. But basically the aim, if you're writing a scientific article and you're conducting your research, your literature review aims to summarize what is already known and what is has been discussed, figured out, discovered in relevance to your research question. It doesn't answer it. It kind of tells us what people have done around your research question. And then hopefully your research question is going to cover something that has not been previously covered. Can we combine both types, experimental and observational, or would it not be recommended? Certainly you can. Most studies actually would start as experimental, especially like when you give an intervention or a study, like they would give, let's say, a chemotherapy for a few months, and then they would follow the patients for 2 years, right? I mean, so basically you started with an experimental design, but then it became a prospective kind of cohort study. And another question, is there a superiority in the methods of one over the other? Meaning I believe the study designs, as we mentioned, there's not, so we know that experimental designs help us be less biased, especially if they're blinded, randomized, well done, etc. But then they are much more costly. So as we said, when you want to choose your study design, you want to do the one that is most feasible and that maximizes the validity of your results. Feel free to stop me at any time, Pratibha, okay? I'm gonna see if we can go over some of those real quickly. Can you further explain how to compare different literature reviews? And are there any standard factors should be considered while comparing the other author's literature review? I'm not sure I got this right. If you want to give me like some explanations, Muna, that would be helpful, please. Shazia, in your experience, what are the most common mistakes researchers make when trying to publish in high-impact journals, and how can they avoid them? Hopefully we can have this question again tomorrow for Dr. Andre, because I think he will be able to give you more, he has much more experience in this than myself. But I would say, make sure that whatever you are sending to that high impact journal is something they're interested in. So figure out what the vibes of the journal are, what topics are they're interested in, and then make sure to have a very strong study. And usually strong studies, powerful studies, require usually bigger sample sizes, more collaborations. They tend to be much more costly. So I mean, make sure that you gauge the work that you have with the types of works that high impact journals are publishing, and if they're comparable, then I think you're safe to try to at least submit your work. But you find like it's very different as far as caliber, quality, the amount of like how big the studies are, the conclusions that are driven, then I think it might not work very well to aim for a high impact journal for this particular research. Do we mention all the data found in the literature review and the references, or should it be a short synthesis? So that's a great question from Radia. So the literature review can yield 100 articles or 200 articles sometimes, or 60 articles. And if you look at most of the journals you would read, you would not find 60 references, right? So most of the time, you need to summarize and you need to focus on the most relevant literature review, which could be 20, 25 usually is like usually most articles. Some articles can go to 40 or 50, depending on how extensive and depending on the type of the article. Are you doing a review, a systematic analysis, meta-analysis? So depending on the article, but it doesn't mean that you have to include all the data that you find in your literature review.
Dr. Abir, I think we can take 3 more questions and
Okay.
then we can.
Sure.
Yeah, a lot of these questions will be answered in the other talks that will come today and tomorrow.
Absolutely.
Yeah.
So I'm going to skip the ones for Dr. Andre and the team.
Yes, please. Yeah.
And Yalla, yeah.
Yeah.
Okay, the points for introduction writing is, as I mentioned, make sure to start wide and then narrow down, zoom in, do a succinct, organized, leading literature review that leads into what's known, what's unknown, and how your question will answer it. That's it, and keep it simple and interesting. We have a lot of questions. So the limitations questions I'll leave for Aniella. She's going to do the discussion section, the one by Faraj. How can I find the research gap for a review paper? I'm going to take that one. So reviews are very critical most of the time, or very, very tricky. Let's put it this way, not critical. So most journals now approach a certain expert to do a review paper, and they do not expect, or they do not really accept anybody to come up with just kind of a review paper. And so so that's why I don't think it's going to be very helpful to do a research gap for a review paper. Having said that, if you have a certain mentor or a faculty or an expert in your school who has a certain topic or area of interest, you can approach them to see if they would be interested in writing a review article, because they're more likely to be able to find a journal or a venue to publish this review. Okay.
Can you take this question on burying limitations or addressing them head on? This should be around where you are right now. Towards the end, Faraj Ghazait.
Yeah. Is it better to bury limitations or address them head on? Yeah, so that one I wanted to give to Dr. Aniella, but I can answer that.
Okay, that's fine.
Because that's going to be in the discussions. Never bury anything. You really need to spell your limitations. But Aniella will tell you hopefully more about that.
Okay.
Okay. Okay, sometimes now some of these have been answered, so I'm not gonna answer questions that I think are relevant to what we did. Yeah, so while doing the literature review, sometimes we find the papers don't give enough details, so it's very hard to know the novelty of our work. How can we deal with this issue? So that's a good question. So the good thing about scientific research, and I think most researchers and scientists would be very happy if you would email them and ask them a little bit more details about how they did their research study, or if you feel like they didn't give you enough details. And so most researcher or all articles, scientific peer-reviewed articles, will have a corresponding author, and often that corresponding author will have their email mentioned on the paper. So what I've done, and it has happened to me before, is I would email the lead author or the corresponding author, and then I would ask for more details. If they have a survey that they did not attach, and I'm interested in to know what the survey exactly included, I would email them and ask them for a copy. And you would be surprised at how much people are usually willing to really discuss and reveal more of their research work. So that would be my advice to you. Okay. I do not want to be taking more time. I don't know if we have any more time to take any more questions.
I think we can stop with this, Dr. Abir, so that Dr. Aniella gets enough time for her presentation as well.
Absolutely. Thank you all so much. And I want to thank the team with us today, and Dr. Andre for volunteering, for helping me give this presentation as well. And I want to thank again the Hamdan Foundation for Medical and Educational Sciences for this great initiative. And thank you for a great audience. Thank you for listening well. And thank you for some very great and insightful questions. I'll be happy to also communicate by email if you feel that that would be necessary. Okay. Thank you so
Sure.
much. I'll need to leave you now, and I'm sure you're gonna have an excellent presentation also with Dr. Aniela. Have a good
Thank you so much. Thank you so much, Dr. Abir.
Thank
Dr. Aniela, it's over to you.
Yeah, thank you very much. Thank you also, Dr. Hani. So I'm gonna share my screen. Okay, so can you see my screen?
Yes, we can.
Thank you very much. So good afternoon to all. Thank you very much for attending this workshop. I would like to thank, first of all, the Hamdan Foundation for Medical and Educational Sciences. Thank you for the organizers. And I would like also to thank Dr. Mgerbani for the coordination. And so I'm happy to attend and to participate actually in this workshop. Before introducing myself, I've included on this first slide my email. So for the attendees, if you would like to get in touch, you have any questions, you have like any clarifications in the future, please feel free to contact me and I would be happy to go to answer all your questions. So I'm Aniela Abizerjes. I'm a PhD holder, and I am currently an associate professor at the LAU Gilbert and Rosemary Shawouri School of Medicine. I wear actually different hats. So in addition to being a scientist and a passionate one, I also I've got a problem with my screen actually. So I'm also I'm a passionate researcher and I'm a basic scientist researcher. I lead a team, a research team, and we work, our interest is mainly to study the effect of diabetes on the heart. So my expertise is related to cardiovascular diseases and more specifically the cellular and molecular cardiac physiopathology. I'm the medical director of medical year 2, and I teach medical students both the physiology and the ethics disciplines, and I'm coordinating also both disciplines. As to give you a brief background, I have a PhD in cellular and molecular cardiac physiopathology from the School of Pharmacy from University of Paris South in France, and also I had a postdoctoral fellowship that I got from the School of Medicine at Marie Curie University. So as Dr. Hani already mentioned, I'm sorry, but I'm having a problem. I don't know what. Okay, so I'm going to continue what Dr. Hani was discussing. So I will discuss mainly the results and the discussion sections of the scientific paper. I'm going to guide you on how to write these sections. I'll try my best to give you some tips, but also to give a little bit or to share a bit of my experience. And then we will finish the talk by addressing key ethical considerations in scientific publishing, including plagiarism. We will talk a bit about authorship and the importance of data integrity and ethics in research. So the first question when we start writing a paper is like, from where am I going to start? So which section I'm going to start writing? And we had this question earlier. So am I going to start with the introduction, continue with the methods, and then the results, and end with the discussion? So I would like to tell you, as Dr. Abir mentioned, there is no right and wrong, but it would be recommended, and this is based on my experience, is that you do not have to go with the same order of the different sections of the paper. I would personally start with the methods and the results section, because by writing or drafting the methods, I would actually have a refresher of all the experiments that I've conducted and then the findings. And then this would help me to write and to finalize the introduction and the discussion at the end, but before writing the abstract. And there are advantages of keeping the introduction and the discussion at the end, because in that case, their contents would depend on the choice of the journal. So by the end of the paper drafting, by the time you have reached the end of your paper writing, you would have, you are more sure about your choice of the journal. So you would be able to finalize your introduction and the discussion. That's one. And second, the fact that you drafted your findings and you had the time to think about them, that would help you discuss them and analyze them in a better way, and to fine-tune again your introduction. And before moving from here, I just want to say that we all agree, I mean, researchers and scientists agree that it is really challenging to start writing a new paper and to remain motivated during the process. So, and my advice for you is that the more you write, the better you're becoming at writing. So do not be afraid to start writing, even if it's not perfect since the beginning, you will be able to make it perfect as you go. So it's very important to keep one thing in your mind when you start writing a paper, it is the primary research objective. So what is the objective of my paper? What is the story that I want to tell to my audience? So each paper, it is one story. So that's why having a clear and concise story would increase the possibility of acceptance of your paper. And you need to decide early on what needs to be reported in your paper in terms of results and what can be omitted. Of course, when we do research, we will be emotionally attached to what to our results, to our experiments, but we cannot report everything. As I said, you need to keep in mind the story, the objective that you would like actually to address. And my recommendation for you, and this also would depend. At this point, the choice of the journal, the timing of the choice of the journal would depend. You will talk to many people, you might have different answers. But from my experience, I would say that it would be optimal if you have in mind early on 2 or 3 journals that are related to the scope of your work. I would go to these journals, I would look at the guide to authors, I will see what are the guidelines in writing the results section, the discussion, the number of words that is allowed, the number of figures, etc., the number of tables, and I will be able to tailor my paper accordingly. Now, of course, I mean, the possibility or the probability of my article being rejected is always present, and I might need to change a journal, but it's not a big deal. You can reformat it a little bit in order to apply to another journal, and that's why I said that having in mind 2 or 3 journals, it would help you narrow a little bit your choices. So the first take-home message that I would like to emphasize on before we dig deeper into the results and the discussion sections is that when you want to start writing a paper, you need to set aside time for writing and choose an optimal environment. We are all running on very busy schedules. We have a lot of distractions. So you need really to check your agendas and keep the time for writing, because getting distracted is going to be very easy. And second, split the thinking from the writing. So you need to structure your complete storyline. And so think about what is the story that I want to tell. And what I would do first is that I can start working on the tables and figures by putting and compiling my findings. And then I can start writing. So always start with the figures and the tables. This would help you to actually structure your ideas and to know what is your objective. Choose the potential journal early on, as I said. You can divide the writing of the paper into manageable chunks, and it's important to have breaks. And most importantly, is like reward yourself. You have to celebrate your win. So every time you've written like a section, you should be proud of it. And another recommendation is that if you have someone you would trust, maybe you can ask that person to read it and to give you feedback. So let's go into the results section. So the first thing that we need to keep in mind when we start writing the results is to keep the storyline of my paper in mind. So what is my main message? So the findings in the results section should match and answer the research questions from the introduction, and they should match also the methods section. So both the methods section and the result, they should be matched. And we will talk about this in a few. So retaining the focus will help staying concise. So decide which findings you would like to include and which finding you would like to keep out. So how do I really draft my findings or my results? So first of all, I would recommend to have your findings drafted in a clear, concise, and objective way. So this is the section where you have to report your finding really in a very objective way, and most importantly, without any interpretation, without any analysis. So if you, the discussion section is going to be dedicated for analysis and for interpretation. In the results section, you just have to describe in a very coherent and in a very clear way with very easy sentences and short sentences what are your results. And mostly you need to write them in a past tense. So the findings or the results usually are drafted in a past tense. So as I already mentioned, results should or they could be a mirror of the methods section. What do I mean by that? What do I mean matching the methods to the results? You know, when I want to write my result, I should have also an outline, like a structure which is coherent, which is going to report my results in a coherent and comprehensive way. So I can look, for instance, at the methods section and see what I did, what are the different steps that I followed. And then for each step I did, or for each protocol that I followed, I can report the findings that I obtained. So in that case, I would have a coherent paper at the end of the day, because now we are, for the sake of the workshop, we are splitting each section aside, but at the end of the day, you need to compile all the sections, so you have like a one story which is coherent. And you know, the results, how the results are presented in a paper, you have to draft them in text, but also you need to present them in figures and tables. And usually the results section is a dynamic interplay between both, between the text and the figures and the table. The most important data will be shown in both. You show them in the figures and the table, and you also need to report them in the text. But not all the data that are in the tables and figures should be reported in the text. Now, the question that one might ask is that if I have more data or more figures that a paper can handle, what should I do with these? This would be dedicated for the supplementary section. You have a supplementary section on the web, which is related to the paper, to the journal. So you can prepare supplementary figures and table that you can include there. So this is why I will emphasize again, is that before you start writing, you can go to the guidelines to authors and see what is the number of figures and tables allowed. So now I want to sit and write my results section. So practically speaking, what do? I decided to take a plan. So this is like an outline for an epidemiology or to basic science also research. I will try to combine both. So in case in the attendee, among you, you have basic scientists or clinical, so you would benefit from it. So a common order of elements is to start, first of all, in the results section by talking about the response rate and the recruitment. And then I will move in second place to the characteristics of the sample. Then I will talk about the primary findings, the primary results, which are the most important ones. Then I will move to the secondary analysis, and I will finish, or I'll end my results section with any additional findings. And when I talk about any additional findings, I mean any unexpected findings, which weren't really related to the main research question of the paper, but they are worth, it's still worth mentioning them. So we will go with each section of this outline, and we will see in more details how we can present them. So we said that the first part of the results section should start with a description of the recruitment or the response of the participants, or rather the yield of other procedure by which you obtain the data for your analysis. So if we take, for example, a randomized controlled trial, for instance, then your figure 1 in that paper is going to be most likely the flow chart of the recruitment procedure. So I'm going to give you an example, but the example that I'm going to give you is related to a basic science research. So this is a figure which is extracted from one of my papers. So you see, this is figure 1, and in figure 1, we are showing the experimental design of the study. So the first thing that is like interesting in this figure is that by looking at the figure and by reading the legend, I would be able really to understand what's going on. I would be able to understand the experiment design that was implemented by the scientists, even without going into the text. So I do not need the text in order to understand what's going on. So here you can see animals, a group of animals was used. It was dispatched into 2 different groups, the control and the diabetic. And then the researchers waited like for 3 time points. And at each time point, so 4, 8, and 12 weeks after injection, they did the different experiments that are listed here. So first, what can I conclude from this figure? So this figure 1 is going to establish the results section by telling me what is the experimental design used in the study. That's one. Second, I will seize this opportunity to tell you that for a figure, we always represent the title of the figure in the bottom. So it's under the figure, which is in contrast to the tables, and we will see this in a few. And the legend by itself, and you can see here, you have a title for the figure. The title is like a short one, which is going to be really very indicative of what's going on. And then you have a legend, which is enough, which by itself is enough to explain and to describe what's going on in this figure. Now, I have this figure 1, which has set actually the foundation of my results section. I need to now translate it into text. So this is the figure, and now I have the results section. So the first paragraph in my results section would be the discussion, or not the discussion, I'm sorry. So this is like the description or the reporting of the characteristics of this model. So as you can see, as I'm writing my results section, I will have to refer to the figures. So it's very important that when you want to start writing your results, as I mentioned earlier, start preparing your figures and tables early on. You have them in a very chronological order, going from figure 1 to figure 6, for instance. So when you want to start writing or drafting your results section, you're also going to start describing your findings, also going from figure 1 to figure 6. So you would follow the same chronological order. Now, what comes in the second place? So the second part of the results would be the description of the study sample. For instance, I showed you the example of rats. My table 1, so table 1 would be the description or the characteristics of my animal group. Now, if I want to do this characteristics, or want to apply this to a paper where I'm talking about a study sample with including human subjects. So what do I include in my table 1? My table 1 is going to include the basic demographic characteristics as well as the major clinical and lifestyle variables. So what does this mean? So this is a table which has been also extracted from a research paper. So you can see table 1 is presented here, and on the right of the screen, you have the characteristics of the surveyed population. And we can start with table 1. So table 1, as I have already told you, the title for the tables is going to be on the top of the table. So it's not the same as in for the figures. We report usually the age and the title. So we report the age as numerical value. So we present the mean and the standard deviation, and that's very important. And tips for you, because, and we will understand why are these details really important. I will explain in a few. For instance, if I'm presenting the mean with the standard deviation here, I presented the mean as 36.2 and the standard deviation at 13.5. So I used 1 decimal in both. So, and it's good actually to have a coherence. So those are details, but these details are going to make a big difference. So this is a table which is showing the characteristics of the first survey population. We've surveyed 500 participants. We have the gender, the marital status, the education level, and other characteristics. Of course, this table can be modified according to your study, what you are trying actually to show or you want actually to inform your audience about. So, and we report here the frequency and the frequency as in the number of the participants and the percentages. And when we want to explain this in the results section, we are going to start with table 1, as I already mentioned, and you are going to explain it. Now, the thing that is important is that the table in itself, it is self-explanatory. However, it's important to explain it a little bit in the results section as in text, but you do not need really to go into much details. So now the third paragraph in your results section, after explaining actually the characteristics of your study sample, you need to go into explaining or presenting the primary analysis or the primary findings. And these findings should be presented early on because you want to stress on their importance. And then you go into the secondary analysis and you end your section, your results section, with a short paragraph on any additional findings, as I said, any unexpected findings. And you need to make it clear in this section that those are coming from post hoc analysis and are intended to generate new hypotheses that are somehow different than the main hypothesis there was for your paper. It is highly recommended when you want to report your findings in this results section to avoid words like remarkably and striking or like it's very interesting. You need to avoid these words because they imply an interpretation of the findings. As we already agreed, the findings should be really reported in a very objective way with no interpretation. And importantly, you can use similar sentences and words to present similar results. So do not try to find in new ways, really. This is a scientific paper. It's not like poetry. So that's why we really need to try to stick to a very concise and straightforward way or language in reporting our data. So as we already mentioned, we need to use a lot of tables and figures. And as I mentioned, you do not have to repeat all the information that are in the tables and the figures in the text. You just only highlight the findings that are really very important to you and that you would like to emphasize on. Now, some important tips that I would like to share with you is use the same order when presenting the data. For instance, if you want to, if you have two groups that you were working on, like an experimental group and a control group, report findings from the experimental group before those from the control group. Second, when you want to report your findings, provide effect sizes such as odds ratios or relative risks, and also the 95% confidence intervals. It's important to report the p-values, that the p-values only are not enough. So you need to reinforce it with the 95% confidence intervals, and we will talk about this more in a few. We talked about consistency in reporting the data, in reporting the findings, and also in reporting or in creating the layout of your figures. So already mentioned, when you want to use or you want to present numerical values with one decimal place, so use it for both, for instance, for the mean and the standard deviation. You cannot do this if your sample size is really very large. And when you want to report means, you have to always report the means with the standard deviation or the median with the interquartile range. So you cannot report only the means alone. And it's important also to present the absolute number of cases in addition to relative measures. It's not enough to say that I had 22% of my participants who were sensitive to the treatment. It would be good also to report these 22%. They were actually relative to how much ineffective. Okay, that's a very important point that I would like to discuss with you. In our everyday language, we use the term significant for anything that is important or substantial. However, in a scholarly article, it is better to use the word statistically significant as to report a difference proven by a statistical test. So usually we report the p-values. So this is a classical way of reporting, but as I already mentioned, reporting the p-value alone is not enough. So you need to add as well the 95% confidence interval because it contains the information from p-values. It shows also the direction of the treatment effect to know whether the treatment had a positive or a negative effect. And it shows as well the size of the effect estimate and its degree of precision. So I included this table here as just to show you how we could present the results. So this is actually a loaded table. So it's a table which is presenting a lot of data. So as you can see, we have the on the top, as I already mentioned, we have the title of the table. And you see that we use lines, vertical lines, in order to frame our table. We do not use horizontal lines. And you see here, we have reported, for instance, the questions that we used or that we asked our participants. Then we have a column for the correct answer. Then we report the proportion having a positive attitude. You see here we have the N, and here we have the percentage. And then we can see that we have the variables that were associated with a positive attitude. We can see the p-value. However, we see here on the last in the last column, we can see that we have the 95% confidence with the odds ratio. So I would recommend that you have actually a good talk with a statistician, a biostatistician, who would give you a better insight about the statistics before you start writing the paper, because you would learn a lot from them. The other point that I wanted to actually stress on is that sometimes in your research or in your experiments, you had some findings that statistically they are not significant, but scientifically speaking or clinically speaking, they are significant. So what would you do in that case? It's not a big deal. If you have like a result which you think it's clinically relevant and it's clinically significant because you are going to interpret it like in the context or with respect to the other findings that you have in the paper, then you can actually mention this in your paper. For instance, I included here an example for you to see. I'm not going into the details of the of the experiments, but here we are looking at the concentration of cyclic AMP in two groups of rats, in two different groups of rats. You see here the difference between the control and the diabetic group at 4 weeks. If we look at the p-value, the p-value was 0.06. So it was like really on the limit. So we mentioned in the text that the cyclic AMP content tended to be increased. We didn't say that it was increased. We said it tended to be increased, and we mentioned exactly what was the percentage of increase and what was the p-value. And then in the discussion, because that was the result section, and then in the discussion, we allowed ourselves to elaborate more on that and to explain why we think that this increase, even though it wasn't statistically significant, it was clinically significant. I would like also to emphasize on something regarding the figure that is shown here. This is the figure with the legend, and on the right is the section of the results which corresponds to this figure. Here in the legend, you can see we have the title, we have the legend that explained what we did, what are the different statistical tests that we run. And usually you have to include in the legend of each figure whether your tests or whether your results are statistically significant or not. So whenever they're significant, you can mention this with a star, and then if it's like less than 0.01, it is 2 stars. If it's less than 0.05, it is 1 star, etc. Okay. And something else that I want to stress on is the quality of your figures and tables is going to be really extremely important. What do I mean by that? Imagine that you are the reviewer or the editor and you need to review an X number of articles every week. So if your article is well presented, if the figures, if the layout is really clean, is neat, everything is present, the reviewer, just by looking at the figures, they would be able to understand everything. So consider that you gave yourself a bonus point and your paper is more likely to be accepted. I'm not saying that the acceptance rate is going to depend only on whether your slides are nice and well presented, but I'm saying that if you have chaotic figures and chaotic tables, then the rate of rejection is going to be higher. So here, if you can notice, we've presented our figures. We mentioned clearly on the y-axis what is the parameter that we are measuring. Here we have like the timeline, and here on the right side we have identified which control, which of the group is the control group, which one is the diabetic one. We had like signs that are very clear, and then also like starting with keeping a certain order is really very important, like a consistency in the presentation. Like we start always with the control, and then we move to the diabetic, control, diabetic, etc. So this is consistency to keep throughout all your figures. And if you are using abbreviations, like for instance, for the control, we have the CON, for the diabetic, we have STZ, you need to keep this abbreviation consistent, not only in the figures and in the legends, but also you need to maintain this consistency in the texts of the results. And I would like also to add the fact that here on this figures and on this histograms, the histograms are showing the average, the mean, and the standard error of the mean. But if you look at the figure well, you can see that you have also the different points. So we made sure for actually a credibility of our results, and because we wanted to show honest, and this is the ethical part. We want to report each individual value that we had in addition to the average for ethical reasons, but also for scientific reasons, because it's important to show also the variability in the group. So the more scientific and more the more clear are your findings, this is going to be better for you. The presentations of your findings is going to be helpful to you. So what is going to be your take-home message too from this talk regarding how to write your results section? So pay attention to write the result section in the past tense. Follow a certain structure in organizing and structuring your results. Start with what is your response rate, the sample characteristics, primary analysis, followed by the secondary analysis and any unexpected also results. Match the results section with the methods section, present the findings without interpretation, highlight findings from tables and figures in the task. The p-value alone is not enough, so you need to add the odds ratio, the 95% confidence intervals, and any table and figure that could not fit to the main paper, to the main body, you can include it as supplementary. I explained, or I went through a lot of details related to the tables and figures. I will just add a few points just to actually clarify this, and so we can wrap it up before we move to the discussion section. So we agreed on the fact that well-designed tables and figures are an efficient way of presenting findings from a study. And I remember someone had to ask a question earlier on, and how would you read a paper? Actually, I would like to tell you that most people, most scientists, including myself, when I want to know whether a paper is relevant to my work, is relevant to me, what I look at are first the title, the abstract, and then I would go into the tables and figures with the legends. So if I find that these are interesting and there is information that would be interesting to me, then in that case, I will go deeper into I will give it more time in order to read the introduction and to read the discussion. So, as I mentioned, it's very important to have a clear illustrations because that would make the reviewer happy. And a happy reviewer is a reviewer who would like your paper, and they would be more willing actually to give you a chance to at least revise your paper if your paper is not going to be accepted directly. I just want to mention that you could use a special software in order to prepare your figures, and that would improve the high quality of them. What is important is that you can go to the guidelines to authors I already mentioned before, and some papers they would let you know exactly about the layout. They would tell you how they would like to have the tables, etc. You need to make sure that all the content of your figures and tables are correct and readable. Now, something that is very important that I would want to stress on, make sure that the figures and tables that you would include in your results section are created by you, and they are your own figures. Do not use figures from other papers and include them. Now, if you are writing a review paper, let's say, a review paper, normally we do not include a results section, but I'm just like making this comment because that would be interesting for you. If you insist on using a figure that was like in a different article, at least you need to take a permission, and you need to include the reference of that paper from which you took that figure. So as we already mentioned, usually the figures and tables are going to be self-explanatory. The legends should be also clear, and you need to include them in your paper by chronological order. So do not make the confusion as having table 2 before table 1 or figure 4 before figure 3. Do not make these mistakes and these errors. These seem to be really logical and very easy, but believe me, there are so many mistakes. They are related to this. And make a deliberate choice early in the writing process on which data to present in tables and figures, because some of the information can be only included in the text, doesn't need to have tables and figures. Usually what I do, if I'm going to report a finding that is not included in any of my tables or figures, and even it's not included in the supplementary figures, I mention between brackets data not shown. Now, if the reviewer would like to see these results, they would ask, and you can include them later on. We talked about the titles. I'm not going to repeat that. The title, it has to be informative, not very long. And we talked about how you need to report the statistics in the legend. And it would be always good to have the opinion of a colleague or an expert in the field to have to give their opinion if you want them to read the paper. And consistency is really a key on that. Okay, so now importantly, let's say that you have prepared your paper, your find, you have picked your journal, and you are ready to submit. So before submission, we agreed that you have to check the guidelines to author, and you need to really pay attention. If the journal is asking you to present, for instance, to include your tables and figures embedded in the results, then you can include them in the results. If they are going to ask you to include them at the end of the paper, after at the end really, and after the references, you have to do so. And some papers, for some journals, sometimes they can ask you to submit each figure independently as a separate file, and they are going to specify whether you have to do them, to upload them as TIFF, JPEG, etc. And my advice to you is that really read those guidelines, because a lot of papers they can read, the editor or the editorial board, they can send you the paper again to make those changes, and that would delay the review process. So follow the target journal's contribution to author for drafting tables meticulously, and make sure what is the allowed number of tables and figures, and don't forget the supplementary method. There is another point to keep in mind, is that journals usually charge for colored illustration. So if you are able to pay that money because there is a fee for that, then there is no problem. But however, if you cannot afford publishing colored illustrations, colored figures, then you can go for black and white or grayscale figures, but make sure that they are going to be readable, because whenever they're going to be printed, the reader will have to be able really to see things. So if you paid attention, in the histograms that I showed you, we used for the control black and for the diabetic white. That was made on purpose because we published these figures as black and white. So, and these two colors, the black and white, they are like the safest colors, and they can be really clear. I explained about the design of the tables. Use the horizontal lines to mark the top and the bottom of the table. We do not use normally the vertical lines. And if you have like big tables you want to fit into your Word document while preparing your tables, you can use the landscape, the landscape page. So the take-home message for the tables and the figures, you have to decide early on what to include as figures. The title should reflect what is shown. Just remember that if you have like a very interesting title that is really making an impact, that would attract the attention of the reader. The tables and figures, they should be self-explanatory. Do not repeat information from tables in the figure in the text, but emphasize on the most important findings, and always design tables and figures to make them clear and easy to read. Now, we're going to move to this last section of the paper, which is the discussion. Of course, we're not counting the references section. So if you want to write a discussion, how would you start your discussion? What is the outline of your discussion? I would recommend following this actually outline. If you follow this outline, it's going to be a good start. And as I mentioned earlier at the beginning of my talk, we can talk for hours about what is the best practice. Of course, I mean, like this workshop is going to help you a lot. It's good to attend as many workshops as you want. They will help you for sure. But the best way to really master the art of writing is to write. You need to write, and the more you write, the better it is. It's not a big deal if you get rejected the first and the second time. The reviewers are going to give you always comments. Take those comments seriously, improve on your paper, and you will have better chances to be accepted. So the typical discussion section consists of a summary of the main findings. So the first paragraph of your discussion is like a summary of the main and the most important results of your paper. So you're summarizing them. And then after this section, you move to the second section, where you are going to start comparing your findings. You need to interpret them. You need to analyze them. So while we said and we agreed on the results section is just a section where you report your results, the discussion is like your space. This is your free space to interpret, to analyze, to discuss, etc. But what do I mean by discussing? Discussing them is like you need to discuss your results as a whole. So each result you got with respect to the other one, because you want to make sure that your story is coherent, it makes sense, and it has an impact and is significant. But also you want to compare your findings with those reported in the literature. And we will see how you would do this in a few. And at the end of the discussion, you can end with the strengths and limitations. Do not be afraid to report limitations, and we will talk about this in a few. And it's always nice to finish your discussion on a nice note by emphasizing the impact of your study. So what are the implications of your findings, how they are going to have an impact, clinically speaking, scientifically speaking, etc. And here it would depend on the scope of the journal that you have picked. So if I picked a journal that is specialized in cardiovascular, and I know that all the readers of that particular journal is going to be, they are interested in cardiovascular diseases, then I need to make this implication relevant to the scope of the cardio, they're going to be relevant to the cardiovascular diseases. That's very important. If I picked a journal that has like a wider audience, it is like relative, and it's very important to my scope, to my research, but it is not very specialized. Then you need, in that case, to tailor the implication and the discussion and even the paper in that direction. So that's why knowing and understanding the journal is very important. Now, I told you at the beginning that most of us, and this is also what I personally do, I leave the discussion and the introduction a little bit at the end. And so how these introduction and discussion are going to be complementary somehow. So usually we say that the introduction can be visualized as a funnel, while the discussion can be visualized as an inverted funnel. And so while you put both of them together, they are going to form an hourglass shape. So keep this in mind while writing your discussion, and it will be a good guideline to you. And something that you need to keep in mind while writing your discussion is like, try to imagine yourself talking to an interested reader. So what would you tell this reader? How would you tell them, how would you explain and interpret or analyze your data? And how would you make this discussion really appealing and you would like to attract the attention of that reader? So the discussion is an interpretation of data. And importantly, I would like really to emphasize on it, you are interpreting and analyzing your data, the data that you reported in the results section, The discussion should never present new results. You have a new results, a new objective, you start writing another paper. So do not mix up things. The discussion should be really clear, it should flow, and it should actually be also coherent. Okay, the main discussion here, the main question here is like when I start writing the discussion. So as I said, that I usually tend, other people might do something else. I tend to keep it at the end. However, you need to keep in mind that the process of the discussion has started really earlier, way earlier than the writing process in itself. So what do I mean by that? I mean by that with every experiment that you've done, with every finding you got, and you analyzed, when you started analyzing your data, so with every result, with every new result, you started actually thinking, you started analyzing, going into the literature to see whether this is a new finding or like whether you are in agreement with the findings in the literature, etc. And most importantly, the group meetings. I would recommend, if you have it already in your research teams, the group meetings, I mean like the research team meetings, that's great. If not, I would recommend you implement it, because during these meetings, when you have the data present, when you have the analysis done, you start like showing, presenting your data. You have the team members that who will give comments, who will give feedback. So they have, they shared ideas and thought. This is like really very important to you and for that discussion that you will write later on. I would recommend that you would take notes with this, keep a list of keywords, because that would help you really whenever you're going to draft or you're going to write your first draft of the discussion. So now that we understood a little bit what is the discussion and what are like the important tips, so what you should do, how you would really write it or draft it. So we said that the first paragraph is the main findings. So you're summarizing your data in order to answer the research question. And I would like to tell you that if you are not able to present the main findings and it's 3 sentences, I would say like 4 to 5 sentences. It means like you've forgotten the storyline of the paper. So go back to your findings, understand them, spend time with your, spend time actually thinking about your results, putting them together so you would be able, so it would be easier for you to draft these results and to be able to discuss them and to summarize them. Do not repeat results in detail in the discussion part, and only use numbers or percentage if they are really necessary for your message. You do not really need to repeat the numbers. You really need to focus on the bigger picture of the results, so you would discuss them. And my advice to you, do not ignore or cover up inconvenient results. If you have results that you don't like and you just ignore them, the reviewers will pick them up. I personally believe, and usually this is what I do when I read my discussions, even if I have inconvenient results that do not align, I still try to discuss them and to explain and to see and to give hypotheses, why did we get this? And importantly, mention unexpected findings by explicitly stating that they were unexpected and do not relate them to a prior hypothesis. And something that I would really emphasize on is honesty. If you are honest in your paper as a whole, in your discussion, in your results, this will strengthen your paper. And believe me, both the reviewer and the editor, they would know this. And usually, when you report your data in an honest way, this would show like high integrity and high ethical values. And I strongly believe that that editor will actually appreciate this. So regarding the section for the strengths and the weaknesses, you know, every study, no matter how excellent it is, it has its limitation. This is a fact. And we should be able to mention the limitations. However, there is a really nice way in order to do it. Maybe you can present the limitations, but at the same time counterbalance them with a specific strength. So, and when I say mention limitations, I'm not saying that you need to stress on it in a negative way. There is always a positive way in order actually to counterbalance these limitations with the strength. And another point is like when you want to compare your findings to other studies, you can, if they are in agreement or they are aligned, then that would be great because that would be reinforcing your own findings. However, if you have data, if your results, they are not in accordance with the previous results, then you can explain why. What are the differences and the similarities? Maybe they got different results because it's the protocols are different, the methodology is different. Maybe we don't have like the same species if we were using animals, maybe the gender is different, etc. So try to understand actually these differences and similarities. Mention the limitations of those studies, but be respectful and objective. You do not gain anything by criticizing badly the other results, the other studies, just like to emphasize on your own. Respect is really very important. Stress what your data adds to the existing body of evidence. So if you're bringing something new to the literature, you really need to emphasize on it. And embrace the uniqueness of the specific study, and always remember to stick to the original storyline of your paper. So I've already mentioned, and we discussed it in details, is that you need to tailor and draft your discussion depending on the scope of the journal. So knowing in advance what is the scope of the journal and what is the audience that would help you tailor your discussion. And usually also I want to mention this. Is that in the guides to author, in the guidelines section, sometimes there is also, they mention a certain number of words that you need to respect. So that's why also it's important to be concise in the way how you're drafting. I would recommend to use the word may, might, our results showed, demonstrate, suggest. Avoid using strong words like we proved or we are sure of. You know, this is science, and your results depend actually on a certain experimental condition. So I would be careful how I write actually, or I draft my sentences. Okay, so avoid also mentioning in the discussion future studies in details, like like mentioning, for instance, that we are currently working on a project and we have shown 1, 2, 3, 4, and you are going to talk about results. First, we said that we do not include in the discussion new results, and second, these results cannot be shared with the editor and the readers anyway. So there is no way to prove that this is accurate. So avoid mentioning things like that, and always end the discussion section with a conclusion, presenting your findings in light of the evidence in the field and the specific strengths and limitations. So try to think of it as the one-liner statement that a reader will keep in mind. So these are the take-home messages for this discussion part. So remember that you have a summary. You have to include a summary of the main findings. So what did we find? Comparisons with other studies, what is already known, what is new, how does this fit in? Strength and limitation, are the findings true? And implications, are the findings important? And what can we do with them? And you're aware of the other ones, so we've already talked about them. Okay, so now in the remaining time, I would like to talk about the ethics in research. This is a very important topic, and also it's a wide topic. And it's a topic which is really very dear to me. However, I will try to go straight forward and to focus on some ideas that are interesting to you. But as I said earlier, if you will have later on any questions, so please feel free to reach out. I will start with this first case, and then we will proceed from. So I've included this case 1, and case 1 states that the research protocol for a study of a drug on hypertension requires the administration of the drug at different doses to 50 laboratory mice with chemical and behavioral tests to determine toxic effects. Tom has almost finished the experiments for Dr. Q. He has only 5 mice left to test. However, he really wants to finish his work in time to go to Florida on spring break with his friends who are leaving tonight. He has injected the drug in all 50 mice, but has not completed all of the tests. He therefore decides to extrapolate from the 45 completed results to produce the 5 additional results. So, so this is the case, and the question is like, what would you think about Tom's behavior? He injected the 50 mice. He had to get the results on the 50 mice because he wants to leave on the weekend. He can collect the data only from 45, but he's intending to use those 45 to produce the 5 additional results and to include in his paper that he did on 50 mice. So that's problematic somehow, and this is like an important ethical question. So many different research ethics policies would hold that Tom has acted unethically because that would be fabrication of data. This is fabrication of data. So, and that's really very bad. What would be the consequence of that behavior? The consequences are many. So one would think that if this paper, first of all, if those results are going to be published, it is true that this study has been conducted on mice, but remember and keep in mind always that the basic science research is a base. It's called basic because the clinical and the translational research is going to be built on those results. So that would be one thing. Second, publishing fabricated data is unethical because that would create false information, false scientific information. And third, imagine also that this research has been funded by a federal agency like NIH or any federal agency. So this agency has trusted actually that researcher, that scientist. They have invested money in them. So, so that's really, really very bad. And that would be considered as a research misconduct. So everything that is related to fabrication, to falsification, or to plagiarism, they are all going to be considered as a research misconduct. But here we need to make a difference between a research misconduct where a certain behavior was intended to deceive, and the difference between this research misconduct and human errors. Human errors that, you know, we are humans, we always make errors, and we call these errors honest in a way because it was like a miscalculation. It wasn't like intended to deceive. Okay, so that's very important. So this is a very important question to keep in mind. And I would like here to emphasize on the fact that a research misconduct, or if you're going to publish scientific data that are falsified or fabricated, or if there is a plagiarism, you risk having your paper retracted from the journal. And this is like really not, this is going to threaten your scientific credibility, and it's going to affect your scientific reputation as well. I know very well that as scientists, we always work under this pressure of publish or perish. However, it's better to publish less, but to publish well and ethically, having this ethical attitude, than to publish more and to have bad data and then having a bad reputation. We are proud when we publish a good paper, because we're going to be cited, our results are going to be referenced, and it's going to be really something good whenever someone is reporting, when they're going actually to publish their own paper, they are going to cite us and they say that our results or findings were reproducible. So that's a good thing. So you see here on the slide, this is the case that happens during COVID-19 pandemic. You know that many papers, they've been actually published, even some of them, even like they were published fast. So there was a question mark about the review processes, etc. And you see that paper was, so that was reported in Science that 2 elite medical journals retract coronavirus papers over data integrity questions. So integrity is a very important question, and this is something to keep in mind. And I also want to draw your attention to something. When you want to read your when you want to read a paper, a scientific paper, when you're doing your literature review and you're reading scientific papers, read them well, because not everything that is published is really accurate. So this is a very important point that I wanted to emphasize on today. So what is actually an ethical conduct? Ethical conduct is literally means doing the right thing, but in reality, it means more than that. It involves acting in the right spirit out of an abiding respect and concern for one's fellow creatures. So you know, all the types of research are interesting, and they are all important, whether the research including human subjects or research including animals. They all need to abide to some ethical guidelines, and we will talk about this in a few. I'm focusing mainly on the human research because many of you, I knew that many of you are coming from the medical background. So human research actually is the research which conducted with and or about the people. And usually this research is conducted and should be conducted or should be approved whenever the sole intention is to do good. And since we are involving a human subject in that research, so there is always a risk. And what kind of risk am I talking about? It could be physical risk, but also it could be psychological. And this could be coming from errors like technical errors or ethical insensitivity, etc. So human research usually, when it has to be designed, some of you asked the question earlier that how can I come up with my research question, etc. A good research question is a question which is going to lead to research that would develop generalizable knowledge, which is going to improve human health or increase the understanding of human biology somehow. So usually, why do we have ethical guidelines? We have ethical guidelines to follow is to protect the patient volunteers and to preserve also the integrity of the science. I don't know if you are familiar with in that experiment that was conducted in Alabama years ago, this experiment or that study involved around 400 low-income African-American men with syphilis. And the problem is, at that particular time where the researchers, they were conducting the study, penicillin was discovered as a cure. So instead of sharing that cure with those participants, the scientists, thinking only about the research, they didn't actually share the information of the cure with those participants. They hide it from them. So just like to gain those participants in this experiment and to be able to publish. So this behavior is completely unethical. I'm going to pass the ethical guidelines, but if you, as I said, if you have questions, you can contact me later on. So why ethical guidelines are important? I'm going to show you nowadays, for each paper you want to publish, there is actually an ethics section that you need to attend to, you need to address. Whether you're working on humans or on animals, you need actually to address it. Usually, in the method section, at the end of the method section, you are at the end of the method section or at the beginning of the method section. It doesn't matter. You need to mention that your study was approved by the ethical committee of your institution. So if your study is going to involving a human subject, so you need to include it. So here, for instance, this is an example of one of our paper that was published. We included at the end of the section, of the method section, that the consenting participants were given the choice to use either the English or Arabic questionnaire, and the study was approved by the IRB committee at LAU. So first of all, consenting participants means that you're involved in that study participants who only consented to the study. So, and some journals will ask even about the informed consent. And second, you have stated it clearly that your study has been reviewed by the IRB, it has been approved. If you do not do this, and I want to mention that it's not just a mere statement. It means that it's not enough just to write it, but we didn't do these steps. So we really need to state that we need to include this statement in our paper, and we need also to ethically abide by it. Another thing that I wanted to say is that BMC Public Health, they requires at the end of your paper, for instance, to include a section of declarations. And one of the sections is related to the ethics approval and consent to participate. So here we've included the study was approved by the LAU IRB committee. We included the number of the approval. So what is the number that was given by the IRB? And all methods were carried out in accordance with relevant guidelines and regulations, and all participants provided informed consent. And even the studies that are performed on animals, they also need to be approved by a committee. So it's not the IRB. The IRB, it's the Institutional Review Board Committee to review the human studies. The ACUC, the Animal Care Use Committee, is going to be the committee which reviews the animal protocols. So here even, so all journals also are going to require confirming in your paper that you are abiding to the rules. So animal care and investigations adhere to the guide for the care and use of the laboratory. So what are the principles that we need to keep in mind? I'm going to go through them really very quickly because I want to spend more time on authorship and the plagiarism. So just keep in mind that we need to be held by social and clinical value, scientific validity, fair subject selection, the favorable risk-benefit ratio, the independent review, securing informed consent from participants, and the respect for potential and enrolled subjects. So what do I mean by social and clinical value? your research question, when you decide to work, when I decide to work on a topic, my topic need to have a certain value, social and clinical value. So only if the society will gain useful knowledge, which requires sharing results, both negative and positive, can expose human subject to the risk and burden of research be justified. So to have this justification, so I need to have a research with social and clinical value. Scientific validity is really very important. So what do I mean by that? If the question researchers are asking answerable, are the research methods valid and feasible? Is the study designed with a clear scientific objective? Is the study using accepted principles, methods, etc.? Why scientific validity is important? Because invalid research is unethical. Why is that? Because it's a waste of resources and you are exposing people to risk for no purpose. Fair subject selection. What do I mean by that? You need actually, how would you decide who are going to be the participants in your study? How you're going to be selecting your subject or your study population in a fair way? First of all, you need to make sure that everyone had their, actually you're recruiting your participants based on your scientific question, means not on vulnerable. You are not going to take advantage of vulnerable population in order to include them in the study. Give you an example for that. If I want to work on a drug that is, I want to test whether a drug has an impact on cardiovascular diseases. So in that case, I need to include in my study people who have cardiovascular diseases versus people who are healthy subjects. But I'm not going to use, for instance, I'm not going to include in my study prisoners just because they are vulnerable population. Okay, so you need to be careful about that. And a study should be approved and conducted if the risk, if the benefits of the study outweigh the risks. And when I talk about risk, I mean physical, psychological, economic, and social. So all of these need to be taken into consideration. Now, a question that usually is going to be asked is that should we pay, for instance, the subjects that are going to be participating in the study? Usually, no, we do not actually pay them. However, there is a certain compensation. The compensation is just for the time. So what does this mean? Let's say that you are conducting a study and the participant who and the person, the human subject who's participating in the study has to take 1 day off from the work in order to come to participate. So in that case, he might have a change in their salary. So in that case, you are compensating only for the time, or you are compensating for the transportation. But if you are planning to give a certain compensation for the participant, it has to be clarified and well stated in your study proposal for the IRB, for the ethical committee. Independent review, your study has always to be reviewed by an independent committee. The committee, just like to avoid any biases, and we talked about the informed consent importance. So I would recommend at this stage, if you want to do research, what I would recommend strongly is like to be familiar with the policies in your institutions. You need to be able to know whether there is an institutional review board, IRB, and whether there is an ACUC, to get in touch with them, see what are the documents that are needed, etc. So you can, when you write your research proposal, you need to approve it by the IRB, you conduct your study, you collect your data, you analyze them, you write your paper, you make sure that everything is ethical, and then you submit to the journal of your choice. Now, what are the issues that are related to the researcher? You as a researcher, what are the things that you need to be careful about or you need to be aware of? So as I mentioned, know and obey relevant laws and institutional and governmental policies. Make sure that you have, when you conduct research on human subjects, you are respecting their autonomy, their privacy. That's very important. Their confidentiality. You're taking special precautions with the vulnerable populations. And when you do research on animals, you show also proper respect and care for the animals when using them in research. And you do not conduct unnecessary or poorly designed animal experiments, just thinking because they are animals. Okay, we really need to be ethical in this respect. As a researcher, you need to be avoiding bias, inappropriate research methodology, and incorrect reporting, and inappropriate use of information. Remember that well-designed studies advance medical science development, while poorly conducted studies violate the principles of justice, and there would be also a waste of resources, which is a bad thing. Now, fraud in research and publication. So what does it mean? What is the difference between fabrication, falsification, and plagiarism? Fabrication of data, this is a de novo data invention. It's like when the data are going to be de novo, invented from the scratch. The experiment has never been conducted. No one did any experiment, but the researcher actually, or the scientist, the person we're talking about, invented the data de novo. Manipulation of data is the falsification. So it means that there was data, the data is here. The findings do not align with the original hypothesis of the scientist. The scientist is not able to explain the data. So in that case, they start omitting values. Okay, this value doesn't correspond, I will remove it, just like to make the final result suit me. And this is a scientific misconduct. Usually, the true prevalence of scientific fraud is difficult to measure, but it is estimated to be around 2 to 14%. But we think this percentage is still underestimated. So, and this is sad. This is a sad truth. This is a sad fact, actually, that there is a lot of misconduct, scientific misconduct. Now, what is a plagiarism? Plagiarism is the use of others' published and unpublished ideas or intellectual property without attribution or permission, and presenting them as a new and original rather than derived from an existing source. So my advice to you, whenever you want to write your paper, you're writing your introduction or your discussion, and you want actually to cite the studies, you want to actually to report studies, you always need to report, you need to cite them, you need to cite actually these papers. So that's very important. And there are tools nowadays, especially with the evolution of the AI, etc. And these tools will check whether there is a plagiarism or not. And I can assure you, and it's really, I mean, very bad if your paper is going to be rejected while the editor is stating that there is a plagiarism. So that's very important to keep in mind. So copyrights are important. When you publish, and I believe you might talk about this tomorrow, more like in the publication process. When you publish, usually you can choose to publish either in open access or in a subscription. But in both ways, you will have a copyright agreement. And usually authors should obtain written permission from the publisher if they wish to reuse the published material elsewhere. So even though it was your paper, if you publish in a subscribed subscription journal, means like if you publish without paying a publication fee, then the material is not yours anymore, and you need to have a permission from the publisher. Now, there is a very interesting concept that I want to shed light on, which normally a lot of people might not be aware of. So is the overlapping publications, or where we talk about duplication or salami publications. So what does it mean, duplication? So if you duplicate by publications, this will violate international copyright laws and waste valuable resources. So what does this mean? What do I mean by duplicating publications? So it's like when you artificially enlarge one scientific word, distorting apparent productivity, and this may give an undue advantage when competing for research funding or career advancement. And how does it happen? So the duplication, publication or redundant publication, this is when a publication of a paper that overlaps, you're publishing a paper, and this paper is overlapping substantially with one already published without referring to it. So, and if the scientific community is not aware of that, is not aware that there was like a previous work in the field, then you would have actually did something, you should have done something that is like unethical somehow. So if you are publishing a paper and you know that your paper isn't the first in its field, so always give credit to those people who were before you and cite them. The salami publication is like, I will give you an example to explain it very well. So let's say that you have a scientist whose objective is to test the effect of a drug on the blood pressure, on heart rate, on the body weight, for instance, okay? The scientists did the experiment, they collected data on these three parameters. Now, instead of writing a paper where they're going to include the data on the blood pressure, on the heart rate, and on the body weight, they are going to make for each parameter an independent paper, and they are not going to say, they are not going to inform the editor that these three actually parameters, they were measured on the same cohort of patients, etc. So instead of making one paper with all the data in order to make a coherent story, they are going to slice it into different papers, and this is defeating the objective somehow. And usually scientists do this in order to increase the number of their publications. So this is a misconduct. So such misconduct, they may lead to retractions of article. So that's why transparent disclosure is important when submitting papers to journal, to declare if the manuscript or related material has been published or submitted elsewhere, so that the editor can decide how to handle the submission or to seek further clarification. Now I will finish my talk on an important point, which is related to authorship. And if there is one thing that I would like to recommend today regarding authorship, and thing that you can actually keep in mind while leaving this session, is that authorship is a topic that is discussed early on. So authorship isn't discussed at the time where the paper is being drafted. Authorship has to be discussed early on among all the members of the teams, and there should be an agreement. First, each member of the team is going to be responsible of which experiments, who's going to do what, and then authorship can be agreed on. But of course, all the members of the team should be aware that this authorship is subject to change in case one of the members of the team didn't actually fulfill their commitment, or they didn't fulfill the task that they were assigned to do. And you know, some people also may leave, some may arrive, etc., in the research team. So that's why everything needs to be discussed. So I would recommend that you go to the ICMJE recommendation, and you can see who's going to be eligible to be an author on the paper. Usually, authors on the paper are the ones who had substantial contributions to the conception of design of the work, or the acquisition, analysis, or interpretation of data of the work. They have been involved in the drafting of the scientific paper or in its revision. They have read and approved the version to be published, and they are accountable of the paper somehow. They are accountable of the content of the paper. So being an author on a scientific paper is really very important for each one of us, so for the development of the career. And it's important to understand the importance of the author order. It goes without saying that the first, the second, and the last or corresponding, they are the most important positions. But what I would recommend is that it's important also to collaborate. Collaborations in science is really very important. So having a name, our name, somewhere in between is also okay, as long as the order of the author matches the investment or the efforts that were the efforts invested in the paper. It means that if I've done 80% of the work, it's very normal that I would be first, but it's not fair to me if I've done 80% of the work and I'm going to find myself in the third position. Okay, but if I find my name in the third position and I contributed really in a way to match that, then it's fine. So authorship is a highly debated issue in meetings. So that's why I said that it's good to start early on. Now, what are the abuses to be avoided when it comes to authorship? First, ghost authors. Usually leaving out authors who should be included, people who worked, but they didn't have their name on the paper, and scientific writers and gift authors, like including authors when they did not contribute significantly. Here, it's important to distinguish between authors and contributors. So people who contributed to the work, but their contribution do not qualify them to become authors, they should be acknowledged in the acknowledgement section. And usually you list their name, you thank them for what they did exactly, and you can tell them that I'm going to acknowledge you. So if they accept to be acknowledged, you include their names, and preferably with a statement of their contribution. The authors, to be able to know whether a person is eligible for authorship or not, you go with the ICMJE actually a checklist that I've already mentioned earlier. So something for the medical students who are among us today, it's important to keep in mind that for biomedical journals, usually the first author is a very important position. Usually this is like the student, the PhD student, or the postdoc fellow. And the last author, usually it is the supervisor. The last corresponding is going to be the most senior person, the most senior actually author, and it is the person who came up with the idea, etc. The second author is also important. Now, the corresponding author is the person who's going to make the communication with the journal. And just know that some journals allow joint first authorship. So if you have two people who contributed equally, then it is important to have, it is good, and it is possible to have co-authorship on that paper. So the corresponding author is the person who's going to make the decision. So when do you discuss contributions and authorship? At the outset of a project, like I already mentioned. So planning is very important. That's why it's important to have a lead author who will make the communication and the coordination with the different actually members of the team, and who would share the paper, who will ask for comments, who will make the submission of the paper, who would do the response to reviewers, etc. Of course, in coordination with all the other actually members. Now, my final comment is like it is requested in the paper and by all journals to include what we call the credit authorship contribution statement. So you need, for instance, to include the names. For all the people you included as authors, you need to mention exactly what was their contribution. And that's like, from an ethical point of view, it's important to give a credit where credits should be given. And to finish my talk for today, it's important to keep in mind, like as researchers, we need to be honest, objective when we report our data. Integrity is important, like do not falsify, do not fabricate, do not do plagiarism. Being careful, avoid any errors or negligence, being open to share idea, to discuss, respect for intellectual property, confidentiality when you work with a human subject. You have the responsibility for publication. So publish in order to advance research and scholarship, not to advance just your own career. So avoid wasteful and duplicative publication. Responsible mentoring is very important. So if you are mentoring students, it's very important to advise them in a way, because you are educating the future scientists. Respect for colleagues is important, social responsibility, non-discrimination, competence, etc. We won't have time to discuss the cases, so I would like to thank you for your attention. And once again, thank you for the Hamdan Foundation for Medical and Educational Science. And thank you also for the organizers. And I'm happy to take any questions you may have. Thank you.
Thank you so much, Dr. Aniela, for this very informative and insightful talk. As we're close to the end of the webinar, can I ask you to maybe select 3 or 4 questions that you would like to focus on, because there are many.
Okay.
Otherwise, I can address some questions to you as you prefer.
Okay, so I will start from the bottom list, because I do not know where the questions for Dr. Abir stop.
Yeah, sure. You can start from the bottom.
Okay, so there is an interesting question about consent, whether there is a difference between a verbal consent and a written consent, and to what degree are they valid. If I start with by taking a written consent, should I continue with the same pattern? Yes. Okay, so I would say here, it's always good to take the written consent, because this is where you will make sure that your participant has really read the consent. They understand really what is the research is about, and it's important that because they will have to sign, and signature is really important. Now, in some types of research, and this is really specific and case by case, and usually it's the IRB who will decide when to go for verbal consent. Usually we allow to go for verbal consent whenever the research is really very sensitive, like if in social research, for instance, if the if the participant is sharing very sensitive information, and so in that case we might accept a verbal consent. But my advice is to go always for written consent with a signature of the participant. Okay. In case of the original research, it's moving. Can you okay, let me see. Okay, so we have a question here about the questionnaire. Should not the questionnaire be translated to Arabic by a medical body and used as a reference by all Arabic-speaking countries instead of being translated? The reason is that the translation could slightly differ between different countries. Okay, that's a good question. Usually what we do is that it depends. Usually we use sometimes validated questionnaire that were already in English. And what we do is that we use the assistance of a certified translator who would do the translation from English to Arabic, and then they will do a back translation from Arabic to English just to make sure that we will have the final result. So, and usually when, but the question makes complete sense. There are also some validated scales that are in Arabic. So whenever they are already present, they will, we can use them. But usually editors, they request to have both the questionnaire in both languages, and even sometimes in 3 languages if we want to include French or any other language. Okay, so okay, so we have, if a research project did not hit the targeted sample size, or the results were not the desired outcomes, do we still carry on with it out of scientific transparency, or should we abort? No possibility of redoing data gathering. Okay, so it's a question from Raja. So Raja, thank you for the question. Actually, it depends. I might need more details in order to answer this question, but what I can tell you, let's say that you have a targeted sample. Let's say that you did like the sample size calculation and you needed 500 participants and you ended up with 200. So in that case, you can present your study as a pilot study. Or like a snapshot, you know, it's the way how you present your study. When you make it clear and you're going to be transparent and you explain why you weren't able to reach your targeted sample. Is it like there was like a challenge? Is it like already a challenging sample to reach? So that's one thing. Now, when you say desired outcomes, this is a bit tricky. Desired outcomes, why? Did you get results and the findings, they are scientifically accurate and credible, but they are not aligned with your main objectives? Like in other words, they are negative results, because negative results, they are still results. Now it will be difficult to publish them, but there are some journals that could still publish negative results because that could advance the science in a different way. So visual presentation of the paper make it more likely to be accepted. What is your opinion on using softwares like LAU? Do you recommend any other softwares to use for clinical research papers? Usually, I think that for clinical research papers, I believe that there are a lot of statistical tools that are used. SPSS is one of them. And you have as well, for instance, Stata and R, etc. So I believe that you have so many softwares. Usually I use Prism. This is a very nice statistical tool, also program, which also generates very nice figures. The tables, usually we do them manually. So should the figures and tables be made and placed in such a way that readers should be able to understand the whole paper without reading the text? So Sohaila, unfortunately, when the paper is published, it is actually publishers would decide on the layout of the article, but you at the stage where you are writing. So let's go back to you as when you are writing the paper. So when you are writing your paper, you need to place the tables and the figures as requested by the journal. So if the journal is asking you to present them as individual, you have to present them as individual in individual files. If they ask you to embed them in the text, and then you do so. You have to go by the guidelines. And later on, the layout of the paper as you see it published, this is decided by the publisher, because you present your paper on a Word document. Okay, so what else? So when drafting each section of scientific paper, how can we maintain a logical flow between sections such as introduction, so that the overall narrative feels seamless rather than fragmented? Yes. So this is why I said at the beginning, I would recommend that you start writing the methods. So you start writing the methodology, because that would be a good thing to remember what you've done. And then you prepare your tables and figures. And from the tables and figures, you start drafting your results. So now that you've drafted your results, you can go back to your introduction and to the discussion. And at the end, when you've written everything, you really need to spend time again reading the whole article and try to make it coherent. So the thing is, like, to have a good thread, you need to work on the connections. So the connection between a section and the other are really very important. But while you're writing, keep in mind your storyline. So as long as you keep thinking about what is the main objective, so this will make your life easier. Okay? So I don't know, do we still have time for more questions?
Maybe we take one last question, please, Dr. Aniela.
Yeah, okay. So, okay, I will look at the time mainly.
There is one from Ren. She's asking if consent forms are necessary if it's a retrospective study.
Usually in retrospective study, if you want to go back, usually you cannot have informed consent for that, because you cannot go and contact the patients anymore. But if you present your study to the IRB, you will have an expedited review for it. So it's important just to get the IRB approval. But usually we don't go back and get the approval, because these medical data, they're already available. So using them while keeping confidentiality, this is important in that case. So you need to promise that you will not go and divulgate any personal or private information of the patient. So then it should be fine. Okay. Okay, how can we avoid plagiarism? That's a good question. I would say that while you do your literature review, that's why it's very important to do a very good literature review and to be aware of all the papers that have been published in the field. And then when you're going to be writing your paper, avoid actually copying and pasting ideas from other papers without citing them. So first of all, copy paste is not recommended. So try to write the ideas your own way and the way you want to present things. And second, it's always you need to cite. Okay, you need to refer back to this paper. Okay. So this is the way where you're avoiding plagiarism. So okay.
Dr. Aniela, I think the rest of the questions will be answered tomorrow.
Okay.
And you had mentioned that you are happy to receive questions by email. I actually pasted your email in the chat. So thank you for everyone who asked questions, and we're sorry we can't take up more time to answer the rest, but we've already passed the time. Before we go, I'd like to remind everyone that for tomorrow's session, please use the same link, the same Zoom link you used to attend today's workshop. And the poll will be shown tomorrow at the end of the lecture, and this will allow you to later download your CME certificate. With that, I'd like to end with thanking you, Dr. Aniela, for the great talk. And thank Dr. Abir, who has left already. Thank you both. It was really great. And we'll see all of you tomorrow.
Thank you very much. Thank
you.
Dr. Stephanie, for the organization, and thank you for the attending. So, bye.
Thank you. See everyone tomorrow. Bye, Dr. Aniela.